Hey everybody, we're going to get started with opening remarks in about 4 minutes. Opening remarks in 4 minutes. Literally same thing. Thank you, sir. No, it's okay. No, it's fine. This is the main points we're recording. Thank you so much. Good morning, everybody. We are excited to kick off day 2 of the Autonomous Agent Hackathon. For a reminder, this is a 10-day hackathon that actually concludes on Wednesday, next Wednesday, and everyone has the opportunity to submit online. Today, we are going to be hosting a wide variety of technical workshops and speaker demos, and currently just going to walk through a lot of the bounties. And real big shout out to all of our sponsors, specifically Polygon, Near. We have, wait, just give me 1 second. I'm gonna start over actually. Hey everybody, welcome to day 2 of the Autonomous Agent Hackathon. My name is Cameron Dennis. I'll be your host for today, and this is, thank you AVP. Want to make sure that we thank all of our amazing sponsors. We have Polygon, Near, NOUS Research, Autonomous, OG, Marlin, Humm, MyShell, Aura, Jensen, Eigenlayer, KXVC, Ritual, Enthir, and Jutsu. We are today going to just announce a lot of the bounties. We did this yesterday, but for everyone else new in the crowd, want to make sure that they're well aware of the amazing opportunities that exist to get paid during this next week to build exciting decentralized AI applications. And so this might take a little bit, but just bear with me here, because we have over $20,000 worth of bounties and over 13 different sponsors. And so just to kick things off, the first bounty is by Aura Protocol, which is a verifiable oracle that all developers need to bring AI and any size compute on-chain. They're allocating $4,500 for builders to leverage their AI oracle to power DeFi applications, content moderation tools, and any new models added to the OAO optimistic ML core. They also have a $100 prize for 5 submissions for people who write videos, blogs, Twitter threads, and any other type of content that explains their ZK oracle, optimistic machine learning, and or on-chain AI oracle to developers. Their website is aura.io, and definitely check them out. They're really, really cool. So next we have OG Labs. This is a modular AI chain with a programmable data availability layer for all AI dApps. They are sponsoring $2,000 worth of bounties for 2 bounties, and the first one, actually both of these, are more content-oriented, so even if you're not an engineer, you do have the amazing opportunity to be paid to write really compelling content, build your own portfolio, and talk about this really cool project, Zero Gravity Labs. And so Zero Gravity is offering $100 for up to 10 people, 10 submissions, to write the best Twitter thread describing how developers can use Zero Gravity's modular technology and build decentralized AI applications. And so that's for 10 different people or submissions. And the second bounty, they're willing to allocate $100 to developers and content creators who write a blog describing how developers can utilize Zero Gravity's modular technology to build decentralized AI applications. A single person is allowed to submit a maximum of 3 posts. So one person is allowed to create a few submissions here, which is exciting. Next, we have Flock. They're allocating $2,000 for builders to use their RAG bot to build decentralized applications. To qualify for this prize, hackers must create an AI bot via Flock's AI co-creation platform and build the dApp around the bot. You can go to flock.io to learn more. They have great docs, and if you haven't checked out already, make sure to check out all these bounties at autonomous-agent.devpost.com. Next, we have Vana HQ. This is a self-hosted portable data and model that's allocating $2,000 to the best submission that builds an app with self-hosted models using the Vana API and the open source Selfie repository, which allows you to run local large language models with private data on your MacBook. Super exciting, and you can check out their docs at vana.gitbook.io/GOTCHI. Next, we have Ritual. This is a pretty cool bounty because even if you don't compete for one of the specific other bounties, you do qualify. Actually, not for this one, I'm sorry. It's for the next one. Yes, so Ritual's allocating a $2,000 for the best app built on Ritual. In case you don't know, Ritual is an open, sovereign execution layer for AI, and they're encouraging you to build fully transparent DeFi, self-improving blockchains, autonomous agents, and more. You can check out their docs at docs.ritual.net. Next, we have Jensen. This is actually the one I was referring to earlier. They're allocating $2,000 just for the best submission. And so this doesn't mean you have to actually contribute to any of the other submissions. This bounty is much more broad, and their whole goal here is to support forward-looking contributions in the AI ecosystem. And I'm very excited about this one because it's very open. So thank you, Jensen, for providing this very open bounty. Next, we have Mintbase. Mintbase is a global digital asset marketplace from everything for NFTs, tickets, music, and more. And they're listing 2 different bounties. The first one is for $1,000, and that submission is to create a cutting-edge NFT document loader for LangChain, utilizing Mintbase JS and the Mintbase GraphQL API. The second bounty is also for $1,000, and it's for any submission, quality submission needs to be approved, that expands the Mintbase ecosystem by contributing to a new and original template. You can check out all templates and what templates are at templates.mintbase.xyz. Next, we have Lit Protocol. which is a key management protocol that allows you to create and control your own keys that can be used to run code, sign transactions on any application. They have a $2,000 bounty for the best submission that creates autonomous agents that does compute with OSS large language models, running on LET protocol, and create blockchain transactions. This one's very cool, relatively broad in general, so you could pretty much integrate LIT for most things that you're working on. Next, we have Exabits. Exabits is another very general bounty, which is exciting, and they are allocating 320 H100 hours or equivalent computing resources for their favorite submission. So thank you to the Exabits, and what they are is a decentralized cloud compute platform for AI. Next, we have Nevermind. Nevermind is an AI-powered decentralized payments protocol that is allocating $1,000 to the best submission that uses Nevermind's interface and payment widgets artifacts to create ChatGPT-like interface where builders can create ChatGPT, instruct it, and then start selling it to users. They need to model it out, copying the paymeformyai.com. Extra bonus points if you integrate the Open Router or NAPTHA's backend for model selection. We do have a couple new bounties, which is very exciting, and these were listed just yesterday. So next we have a bounty from Marlin. Marlin is a verifiable computing protocol featuring trusted execution environments and zk-based coprocessors to delegate complex workloads over a decentralized node network. And they are allocating $5,000 to the top 2 ML-based applications. That's actually $500. They're actually listing about 6 bounties here. The second one is for the top 2 applications automated that are related to DeFi, trading, and structured products. And each of those bounties are $500 each. Those are for 2. Another bounty for $500 for the best auto contract execution. This is really relevant for DAOs, governance, and risk management parameters. Next is another $500 bounty for the best social application for something like a recommendation engine. That's for $500. Next, we have another $500 bounty by Marlin, and that is for the best creative applications, and this is more related to NFT and games. And then lastly, 2 other bounties for $750 each for top 2 novel models trained and fine-tuned on Oyster. So thank you, Marlin, for your generous $5,000 bounty proposals. And next up, we have Autonomous, or Olas. And Olas is a protocol and tool set for building autonomous agent economies. They're allocating $3,000 total, and they have these amazing pathways. So you as a developer can just follow their pathways and get $500 in USDC for the top 3 submissions. And that is primarily for prediction agents, mechanisms, and AI tools. Another $500 in USDC for the top submission to be minted on chain. And the last pathway that they have is for $1,000 for the top submissions, and this one is for building your own service. So definitely check out Olas. All of these people do have support channels. If you go to the dev post, these support channels are there. So they have engineers and developer relations people to support you across your journey. I don't believe I'm missing anyone. I think that is it. And lastly, we just want to shout out to all the sponsors who aren't listing bounties. So again, thank you, Near Foundation, Polygon, NOUS Research, Autonomous, OG, Marlin, Jensen, Aura, MyShell, Humm, and Eigenlayer, KXVC, Ritual, Aether, and Jutsu. So today is the second day of the kickoff. Keep in mind, this hackathon is running for the next about 9 days now. So submissions end on Wednesday. That is, submissions due date, Wednesday, March 7th at 8 a.m. Pacific. Judging starts on Thursday, March, I believe that's 8th, at 9 a.m. Pacific. And then judging ends, Thursday, March 7th at 9 a.m. Pacific. Judging ends on March 8th at 5 p.m. Pacific. And then we're going to be actually hosting another decentralized AI event at Stanford University, where all of the winners will have an opportunity to demo, assuming judges complete the judging in time. So that is about it. I'm super excited to welcome our next, our first technical workshop of the day. We have Jared Watts from Polygon talking about Polygon ID. So if you want to come on up, Jared, and give the whole audience a good lowdown. Thank you.
Is this the clicker? Sweet. Hello, everyone. Thank you for joining me in the freezing cold. I'm excited to be here. I think I missed some of the talks yesterday, but I thought about what I could talk about from a Polygon's perspective. I got asked to see what Polygon's direction of AI was, and I thought to myself, well, how about I take the contrarian approach and see how Polygon is trying to kind of combat the AI and the bots that we see in Web3 and crypto today. So today I'm going to be introducing, I feel kind of weird standing in the middle of my slides here, but I'm going to be introducing Polygon ID. And Polygon ID, for those of you who don't know, is our decentralized identity platform that is actually kind of spun out into its own company as of a couple of weeks ago. So first, I'll introduce myself. So I'm a developer relations engineer at Polygon Labs. I've been here for about 9 months. And basically my job is to help people build on Polygon and understand the tools and products that Polygon is building. You can follow me or find me on Twitter, YouTube, whatever you want. I'm on pretty much everything. You can just search for my name. All right, so I'm not going to waste any time. I wanted to introduce what Polygon ID actually is. So I'm just going to use my voice because I want to read the slides. Polygon ID is essentially an open source system that allows users using zero-knowledge proofs to prove some aspects of their identity without revealing that information itself or anything about why that information is true. And the second point here is essentially, it's in a nutshell, in one sentence or 5 words, it's using zero-knowledge proofs to hide PII, which for those of you who have ever worked in data analytics or stalking people on Facebook ads or anything like that, that basically means anything that you can associate to an individual. So that could be your full name, your address, your date of birth, your nationality, any aspect of your identity. And often we don't want to give this information away to anyone, really. We don't want to give it away, especially to online. Oh, I'm going to use the mic. Sorry. Oh, that'd be great. Thanks. Thank you. That's better. Thank you, sir. Thank you. Cool. So yeah, in a nutshell, we're basically trying to prove some aspect of our identity to typically applications that want that information, but we don't want to give that information away. All right, so I'm sure if you're in Web3 and especially at ETH Denver, you've probably heard this sentence about 500 times in the past month, but just as a quick recap and to try and solidify what the purpose of zero-knowledge proofs are, I just have like 1 or 2 slides to go through this and put the zero-knowledge proofs in the context of Polygon ID. So the goal of zero-knowledge proofs here is to prove the validity of a statement without revealing that statement itself. So I want to prove to you that my name is Jared. I want to prove to you that I'm from Australia. I'm working at Polygon. But I don't want to tell you any of that information. I just want you to know whether or not that is true or false. And this system, typically, you can kind of simplify it down to 2 parties. The 2 parties are the prover and the verifier. So these names are kind of self-explanatory. The prover is trying to prove something. So for example, if I was trying to tell you that I am in fact named Jared, I am in that situation the prover. And if you're wanting to know my name and you actually want to verify that that is true or false, you in that situation are the verifier. And the thing that gets passed along is often called a witness. The piece of information that you want to provide is often called a witness, and that is kind of abstracted in the form of a zero-knowledge proof. So the prover provides zero knowledge proof to the verifier, who then verifies that zero knowledge proof. And the outcome of that whole system is to basically say, well, yes, I believe what you've said, or no, I don't believe what you've said. So if we kind of put this in the context of SpongeBob here, this is like an imaginary situation where SpongeBob's been pulled over, he's been speeding in whatever his car is, and the policeman or the police fish here is basically going to say, hey, I want to find out some specific piece of information, such as if SpongeBob is actually a qualified driver, and he has a valid license, let's say. He just needs that one piece of true or false information. But in the real world situation, you know, when you or I get pulled over by the police, or SpongeBob gets pulled over by the police, he has to hand over a huge amount of information with typically your license, right? You're going to give the license and registration over to whoever is pulling you over. And on my license, I have my exact date of birth, my full name, where I live, my signature, so much information that I don't want to give away, yet I'm kind of forced to actually prove this one tiny true or false piece of information to this policeman here. So what zero knowledge proofs enable is to actually prove that true or false statement without handing over the information itself. And especially important in this part is I'm actually not only not handing over the information that the person cares about, but I'm also not handing over all of that contextual information that goes kind of alongside that document that the verifier trusts. So zero knowledge proofs, the TLDR, especially in the context of Polygon ID, is that they enable us to prove things without revealing what that thing is or why or how it's true. And the verifier is still satisfied because the criteria that they're checking is still kind of satisfied because they end up with a true or false statement from this full process. All right, so I'm going to introduce a third party to this prove of verifier system, which is called the issuers. So issuers are the ones that generate these documents called verifiable credentials, or VCs. So verifiable credentials, as you can see in this screenshot on the right-hand side here, is an example of what a verifiable credential might look like. So this is a credential that contains my birthday, and then the document type is just something that's specific to Polygon ID right now. This is not my real birthday, it's just a test, so it's just an example of what one might look like. So on the right-hand side, we have a credential that the prover is given by the issuer. So the prover, for example, SpongeBob or myself getting pulled over by the police, would hold this in either their wallet or any of the kind of open source apps built on the Polygon ID protocol. So issuers, and we'll talk about what an issuer is and some examples in the next couple of slides, issuers are the ones generating these VCs and giving them to the provers. So some examples of an issuer might be the government. So the government would give you some credentials to say, hey, you are of a certain nationality. This is your full date of birth. This is your full name, right? Some personal information in the form of a verifiable credential. Another example might be, for example, universities. So universities, the obvious use case here is to say, well, you've actually graduated with this degree, with this GPA or whatever is used in the US here. For me, it's like a grade that you get along with the document that you get for graduating. Another example might be hospitals. Maybe this is actually kind of an interesting one, right? Because you don't want to give away a lot of the sensitive information about your health conditions or some problems that you might have with your health, right? So these verifiable credentials have a lot of power, especially when they're given from entities that a lot of applications are going to trust. And the final example that I put at the bottom here is your backend. So the great thing about the Polygon ID protocol is that anyone can actually build on top of this, right? Anyone can be an issuer. That means you could be running any custom checks and issuing any custom verifiable credentials to any of the users of your application, or in our little analogy here, the provers in this system. So that could mean you could, on your API, let's say, plug into a Web2 API to say, maybe, for example, the Twitter API. You could say, hey, does this person actually own this account? Does this person have a certain number of followers? Or this could also translate to things on chain, such as, does this person hold a certain number of tokens? Does this person hold an NFT? And award a verifiable credential that the user can then use to prove pieces of information without giving that information away. So if you revisit our bikini bottom analogy here, we've added a new player into the mix, into our proof of verifier system, which is Mrs. Puff here, which is the issuer. So the issuer in this situation is kind of, if you've never watched SpongeBob, Mrs. Puff is the lady who runs the driving academy and gives SpongeBob his license. So in our zero knowledge proof world, the issuer would grant the prover a verifiable credential. In this case, let's say it would say, yes, SpongeBob is a qualified driver, or yes, SpongeBob's name is actually SpongeBob, and his license is valid until a certain date, and the rest of the system remains the same. An important thing to note in this slide is there is also a relationship between the issuer and the verifier. So importantly, the verifier can actually list what issuers it wants to trust, okay? Because let's say if I just gave myself a verifiable credential to say, yes, I'm a qualified driver forever, and I can drive high-speed motorcycles and trucks, I could do that to myself if I wanted to. The verifier doesn't want to trust those kind of sketchy or verifiable credentials from any source, right? It wants to say, hey, I only want to trust the United States government as an issuer. I only want to trust these institutions as an issuer. So there is an aspect of trust between the verifier and issuer where it can say, hey, I only want to trust certain sources of verifiable credentials that the prover can provide. So here's like another example, and the reason I made this slide is the credentials, importantly, can be used for any number of applications, right? It's not a one-to-one relationship from credential to application. So I just put like some stupid examples that I came up with of different applications that you might want to provide these zero knowledge proofs for. So for example, Stake, for those of you who don't know, it's a gambling website. Maybe I don't want people to know I'm gambling, I don't want to give a gambling website away my full identity, that's understandable. You could relate this to some other sketchy websites as well. But you don't want to give your personal information away to these websites, but these websites have a legal requirement to say, is this person over the age of 18, or is this person within certain jurisdictions of the world? And that can be related to things like Coinbase, for example. They only want to serve certain customers who have verified their information. And if you've ever used Coinbase, you have to upload full picture of your license, full picture of your passport, and that's just an uncomfortable situation for users to be in. The same would go for things like games, like League of Legends. In some countries, you have to have a certain age to play these games. You are only allowed to play these games for a certain amount of time per day. And the same goes for any social media app. They all have these legal requirements where you need to prove some aspect of your identity in order to use the platform. But either they just have a checkbox that you say, yep, I'm over the age of 18, and we all know that that is abused by teenagers and has very negative effects, but that is probably a topic for another time. So the point here is the credentials that you receive, let's say I received a credential that I'm 25 years old, I can use that for any number of applications that want to check that information. And this is just another third example. We probably don't need to go too much into detail here, but an example here would be me graduating from Harvard, which I did not do, and I get a verifiable credential, and I can then use that for things like job applications. Right? This is a common example of people faking what degrees they got and what universities they went to. What if we had a system in place where you could actually prove that information to these people searching for it? Okay, so we've talked a lot about Polygon ID, and I obviously know this is an AI presentation, so where is the AI? And I thought, like, how can we actually relate this back to what's happening in the space today and what this has in common with the AI that we're talking about? So I kind of took this approach to say, well, AI can be used for good things in blockchain space. It can also be used for bad things, right? And what we're seeing recently is this kind of airdrop meta where people are creating bots or full-on farming operations to say, I'm going to perform certain actions on chain to try and qualify for this kind of money printing process that is the airdrops from things like Starknet recently or in the Solana ecosystem. depending on how degenerate you've been, you've qualified for these different airdrops in different ways. But there is, like, from what I've heard, I don't know this for a fact, but there is literally full offices of people running these bot operations to try and qualify for these airdrops that chains are running. And obviously these accounts are not human, and my personal take is like a massive percent of the activity that we see on a number of L2 and Alt L1 chains today is actually just bots kind of trading between each other. So how can we prevent these kind of Sybil attacks that people run using a system such as Polygon ID? And hopefully the answer is kind of an obvious one, is you can provide these verifiable credentials to add a layer of kind of proof of humanity to these processes. So you could prove your users are human based on your own custom criteria to say, I'm going to award a verifiable credential to users who meet any criteria that I want. That could be having a verified Twitter account. It could be being verified on some other platform. It could integrate with other on-chain decentralized identity platforms like Gitcoin Passport. Do they have these credentials available associated to their wallet to prove that they are actually a human and not a script running in an office? You could also do the same thing, like for example, the Starknet airdrop. They didn't want people from the US to claim because I think it's a bit of a legal mess for US people to actually participate in these airdrops. So you could prove your users do not have some attribute, such as require them to have a verifiable credential, that they are from a certain country, right? They have that piece of information associated to them, but that value is not from the US. So you could do this to kind of filter out exactly what criteria you want these humans to actually have, and use that to control what rewards you're giving for your protocol to actually decentralize the, decentralize the governance of that protocol that you're building. Sweet, so I was kind of hoping that I would have my laptop here, but luckily I have screenshots in the deck as well. So depending on how much time we have, I'll just quickly check. We've got, I think we're a little bit over time, but that's okay. So I wanted to show you what this actually looks like in practice, right? So what does this actually look like? This is a two-step process that we can break down. So the first step for provers is to say, well, how do I even get these credentials, right? How do I get one of these credentials and associate it to my identity? And this is what we're gonna go through. So the first, this is, before I go through these screenshots here, Polygon ID does run their own application that is built on top of the protocol called Polygon ID, and it's available on the App Store or on the Android store, whatever you're using. But importantly, this is completely open source, so anyone can build this exact same application and run their own custom implementation of this as well. So this is step number one. The prover wants to get a credential. So the process that they would do is they would visit a website to say, okay, I've proven some aspect of my identity, I'm ready to receive these credentials. They'll scan a QR code, and that leads into step number one here. So sorry, that's not step number one. Step number one's on the other side. So step number one is on the right. I think I messed this up. Step number one is on the right, where you can see it says this organization is ready to give you a credential. And what that's doing is saying, well, you've somehow proven, based on your application's backend logic, that I'm ready to give you this information that you can hold inside of this open source protocol, but more importantly in this application that you can use through any number of applications to prove aspects of your identity. So the first step is to say, hey, I'm actually going to accept that this application has given me a credential. Once you click that accept button, this is the second screen in the middle. Some reason I did right to left, so that's my fault. But you can see my data. I have two verifiable credentials so far. And if we click into one of these credentials, here's what that actually looks like. So you can see here is my birthday, and here's like when it was awarded, what type of proof it is, and all the technical details of who this was issued by, which is important here. As you can see, maybe you can't see, but down the very bottom you can see that this was issued by a certain issuer that is going to be used by certain applications to say, hey, I only want to trust certain people who gave out these credentials. So sorry, I did it in reverse for some reason, but that's the first step of the process to receive a verifiable credential as approver from an issuer. So step number 2 is now I have these credentials to say, yes, I was born in 1996. I can actually prove that to verifiers. In this case, it's going to be applications that want to prove the users are of a certain age. So hopefully I've done it in the right order this time. There we go. So on the left here, this is the first step of step number 2. So the process for the user to prove they are of a certain age, for example, would be, again, they scan a QR code on the website, and this will take them to this stage of the proving process inside of the Polygon ID application. So the first step here, as you can see, this organization requests the following information. And you can see it's asking if my birthday is actually of a certain age. And the format that it does that is your birthday smaller than or greater than a certain date? And you can see I passed that criteria. This information is not presented to the application. Importantly, when I click approve, this middle process occurs. You can see it's saying generating a zero-knowledge proof for the credential you're ready to share. So the application never receives my birthday. It never receives any personal information about me. All it receives is this kind of mathematical representation of that information. And the final step is the proof is generated, and the application will accept that information as it verifies the zero-knowledge proof that it received on its server or its backend. And that's pretty much it. So I have a little bit of time for questions, I think, if you have any. But yeah, thank you very much for coming out in the cold and listening to me talk. Is there any questions, or are we all good? Not airdrop specifically, but we're kind of in the development phase right now where we're working with banks as an example of an institution that is interested in saying, well, here's some pieces of information that we want our users to hold but don't want them to share with other companies. I can probably talk to you more in private on like what specific applications are working with Polygon ID and find out more information on that as well. Yep. Yeah, great question. So there's actually 2 approaches that you can do. You can do this on-chain. So there are smart contracts on the Polygon chain that allow you to perform this full flow of verification on-chain. But the example that we demoed here today was this is all off-chain. So my phone is just holding verifiable credentials, and the server that I built, I did have a little website demo that maybe I can show if you're interested later, but the server that I built is just a Next.js app. The server says, okay, I'm going to accept the proof, and then it just runs that verification logic and spits out the outcome of, yes, that verification process was a success or not. So there's kind of 2 different approaches that you can take, on-chain or off-chain. Yeah. Sweet, thank you.
Great, so we are just waiting for our next speakers. They have not arrived yet, so they'll probably get here in about 6 minutes or so. So feel free, grab some muffins, grab some coffee, hang out for a bit. We'll get going with our next discussion right when they arrive. So thank you.
We're good. Sweet. So we can just go whenever? Awesome. So, hey everybody. Thanks for coming. We are Humm.XYZ. We are making the future of IP endorsed AI ownership. So what's the current landscape of AI ownership right now? So currently, OpenAI is getting sued by the New York Times for using their data and their models. Some of these unrelated text-to-video companies are afraid to create videos of real people just because of defamation issues, some legal reasons. And it's impossible to trace some of these IP, some of the input data and the output of these LLMs. So what do we think the future of AI and blockchain is here? So we believe that everyone will have an AI agent of themselves at some point. So everyone here in the crowd will eventually have a version of yourself. Whether you want to sell that to someone, whether you want to use that for personal gain, whatever that may be, you will have an AI version of yourself. We want to make sure that when you have this agent, you're actually able to set limits on it, so you have full control of the interaction permissions, whether that's, I don't know, OpenAI making a bot of you, or any sort of manipulation of that AI self. We see the future being that the ownership is split between the devs who are going to make your agent and yourself. So whenever you monetize off your AI self, so do the developers who made it.
Hi everybody, I'm Will. I'm also a co-founder at Humm. And just to outline Humm's vision for the future. So the first problem that we wanted to tackle was, how do we actually incentivize people to upload their data, right? Right now people try their absolute hardest to keep it secret, and for good reasons. If you look at companies like OpenAI, they monetize your data without your permission and you get essentially nothing in return. The second aspect is on-chain inference. So we're using OPML right now as a way to actually prove that our model's outputs are indeed the output of the given model and the input data that's required to make the inference. So the reason that this is so important is because if you have some central entity right now and say they have several models, there's no IP issues with using expecting one model and getting the other. But if you start training on users' data where you're expecting to monetize that data and actually endorse it, it becomes a lot more important to actually prove that the model output is indeed what you were expecting. The next aspect that we're tackling is inefficiencies in the current market for data. I'll get into that a little bit later, but essentially anonymization laws make it very difficult for users to choose how much their data should be sold for, and also for users whose data is significantly more valuable to actually be sold for a lot more money. And the last tenet is empowering IP owners to have full control of their data. So I think I want to tackle this first one first. Why would people upload their data to Humm? And in the case of an AI agent of yourself, the first answer is better model equals more money. So right now, our default way of training models is simply to scrape Twitter data. So this works decently well. However, it would be improved a lot by email data, message data, and all the other private data that you have on your phone. There are several companies, Spiffy is one, which train models on your email data to try to make emails in your exact tone, and we're trying to replicate that for AI chatbots. And the second is, what else are people doing with it right now? People are essentially giving away their data for free to companies like Meta, and they're not getting compensated for it.
Cool, so how does that look? Right now, we're gonna have some developer that makes, let's say Alice is the framework here. So the developer will give all the public data that he has to make an Alice agent. We'll have some user that wants to interact, so whether that's someone who just wants to talk to the Alice agent, maybe they'll pay for that a certain amount, and that will go directly to Alice's wallet. Since it's used for Alice's IP, it's her complete agent. Any money that goes to Alice's agent should go to Alice's wallet. And when Alice says the okay, like, okay, this agent does represent me correctly, I actually want this to be shown to people, Alice can submit her custom data, maybe that's private data, like Will was saying with the messages or emails, then the developer will start to get paid. So this is what would happen when Alice does not accept the current agent. So when it's attached to her IP, but she didn't accept what it's saying, what it's doing. The developer doesn't get any money, the agent gets shut down, and Alice gets whatever money was made in the meantime. So right now, this is sort of just like the basic outline of how that looks. The developer is just putting in data. Eventually, we want to move this to more of a interoperable ability. So right now, we would have our app layer where Alice's agent can interact with the developer who creates it and the user who wants to talk to it. The app can then query a contract that has Alice's data. Currently, Alice can have preset permissions, like maybe, yeah, give out my data to anyone as long as you follow these rules and you're compensating me in this amount. Then she can send the data back to the app layer, which will make the agent better just in the long run, just as it was in the previous slide. But now, Alice can also interact with other apps. So Alice can export this agent, or just give it the data. But Alice can export this agent from the front-end app, give it to a, let's say, gaming app who wants to use Alice's NPC or Alice's agent as an NPC. So now she can control all of this single agent that the developer has made for her. It's been refined, and now it can be given to a bunch of different apps. And all of this is attached to her wallet, so any revenue she makes, or any revenue these app layers make will go to Alice's wallet.
Yeah, so to dive back into the second tenet of our company is provability of model inference. Right now we're using OPML just for speed reasons, and we think this is very important because without this, it's very difficult to actually track IP associated with a model. As James mentioned earlier, tracing what an output of a model was actually trained on that gave it that output is essentially impossible. So right now we're focusing on fully modularizing what models are trained on what data in a way so that when an output comes, we know exactly where it came from, what IP it was tied to, and who should be compensated for it. Additionally, I think that interoperability is a very important thing that we're trying to do down the line, especially with these models. We could eventually have one language model querying another language model. For example, you could have permissions where GPT-4 could query a language model trained exclusively on your data in a way so that there's no difficulties in proving ownership in the case of, say, the New York Times.
And so this is how we would interact with, right now we're talking with Aura protocol, which is basically abstracting all the machine learning, basically just model generation. So what we'd be doing is we'd be sending in Alice's data from her contract with whatever request comes from the app layer. So let's say it's the gaming company who wants to request a response from Alice's agent. That request will be sent to Aura, which will do all of the model work on their end, give us a response with a proof that indeed the output of the model was with the data. And we can send that response back to the app layer. And this way, we're never actually sharing Alice's data and Alice's model with the app layer at all. So she can just basically keep her data, obviously, somewhere off contract, some secure storage, and then the app layer will never be able to access her data.
So to jump into the next aspect of our company is empowering the IP owners. So we really want to leave the control of the agent, even though it might be public to everyone to interact with, up to the agent. So right now we're programming it so that IP owners can, one, choose what data their model is trained on. So this could include both uploading data or choosing to abstain from using certain data, like Twitter data that's public or even other public transcripts, etc. The next way that we're empowering the IP owners is through allowing them to design equity splits. So there's a big technical moat for users to really monetize off of, or profit off of the AI revolution. And that's because if you're not an engineer and you don't have equity in a tech company, it's very difficult to actually make money. However, what we're trying to do is tie IP owners to developers in a way so that IP owners can actually make money off of their own data. And to do that, we need to allow them to design equity splits with these model developers in a way that's fair. Lastly, we're making it so that the IP owner can always turn the agent completely off if they want. We think that this is very important just to promote Promote the ability for IP owners to have control over their data.
Sure. So this is the future of how we see, sorry. This is the future roadmap for Hum. We see individual agents as only being the starting point. We could have multiple agents, such as companies that have multiple individuals that build a single agent. It could be, like, there's many different avenues. Many of them could be a combination of individuals. We just want to be able to promote interoperability. Obviously, if you have an agent that's really, really good, you don't want to just hold it on one app layer. You're going to want to divvy that amongst many layers. And also, we want to become the go-to platform for these IP-endorsed AI models and training and actually refining these models. But, sweet. Any questions? How's it going?
Yeah, that's very much still up in the air. Realistically, off-chain somewhere, just because especially if open source models eventually catch up with, the size of GPT-4, and we have all these trillion parameter models living in the ether, it's going to be too computationally expensive. So probably somewhere off-chain, but it's something we're still talking about as a team.
Yeah, so we're a few days out from launching what we want to at the moment. So give us some time and we'll get it out to you. But the first iteration will basically be trained, like 50, or we're gonna throw it out to the community to sort of build out like the first iteration of bots based off of, or agents, and then we wanna have them being sort of like interactive agents at the moment where anyone can interact with, let's say like Elon Musk's agent. And then that can be sort of refined by the developer, obviously with more middle tier level status people. Maybe they'll go claim it. Obviously, Elon's not going to go do that. But we do have claiming operations already. So if Elon Musk does go on, a developer did create his bot, he can claim it and now start to accrue revenue based off that. Anyone else? It's probably the flywheel of getting these developers and users on. Obviously, like, yeah, if we had a ton of developers on that were making all these cool bots, we would be the default platform for that. It's just a flywheel thing. But it's probably, yeah, getting developers on to build these agents, I would say.
And just to add to that, we think that sort of migrating users to upload data that is not publicly available is also going to be a bottleneck, just because a lot of people who aren't crypto native won't understand the privatization and the verifiability, et cetera. So we anticipate those being the two main challenges. Awesome. Thank you guys so much.
Great. Ethan, ready? Great. And up next, we have Ethan from my show.
Yeah, I'm Ethan from my shell. So I think today's storm is really huge. So we have so few people. But I'm gonna talk about the future of the creator economy, especially how the AI and crypto can drive the innovations. So basically, we can go through the history about the creator economy. I think there's one more thing. There's one thing that's particularly important is that what can creator build that can be consumed by consumer. I think in the long history, all the creators can do is write the article or the novels, post on Medium or in the in Mira, in the Web3 space. And people can also shoot the photos or post your arts on Instagram and also Zara. The same for the videos on TikTok. But nowadays, with the generative AI technologies, the creator can actually build an interactive AI application without codings at all. So I think we saw the trends of the content that can be built by creators is getting more and more multimodality, interactive, and it's becoming also very modular. Because in previous sense, the articles, the images, the videos is just created by one creators. There's no collaborations at all. But I'm gonna explain why it's getting more modular in terms of the AI applications. So I think in these 2 days, there are a lot of AI events and people are talking about different things about the AI agents and also AI applications. So I think in our definition, the AI application basically is a composition of multiple AI models inside a agent framework with a modular UI. What this means is that there's different kind of AI applications in different kind of content categories, including entertainment for the AI characters or for the educational content, and also for the personalized workflow. The multiple models is that rather than just simple chatbot with single large language model with prompt, we can orchestrating all the models together in an agent framework, which can be either simple in a linear forward flow or can be a dynamic graph transition. And the modular UI means that people always think the AI application is just chatbot, but I think chatbot is just very simple ways for user to interact with early stage AI applications. But we also that we can also use AI generated GUI and also for the voice chatting. So here, gonna give you guys a few concrete examples of what is meant by AI applications. From the simplest ones, basically we can use, this one is a code writer. We can just use one model, it's a large language model with a simple prompt. So this is gonna enable the developers to use the AI to write the code to debug. And what if we have one more model, it's a voice model. Oh, there's no sound. Anyways, basically, it's the large language model is shaping the character's personalities, and the voice model is doing the voice clone and also text-to-speech to give the character more unique voices other than the unique personalities. And also this one is an image generator. It's a large language model and stable diffusion model run in sequence. Well, and in the previous example, yeah, I forgot to mention, this one is actually run in parallel. And this one is run in sequence. Why we need a large language model here? Because Stable Diffusion actually takes the image prompt, which is very daunting and hard to write. So with large language model, it's gonna understand the user's intention, what's the user want, what's the image style, and it's gonna write the image prompt for the users. And the image prompt gonna be forwarded to the Stable Diffusion model as input to generate multiple images. Even at the bottom, there are 4 buttons that can use other models to upscale the image or do the variant. And in even more crazier settings, it's a video summarizer. What if we came across the video on YouTube that we find it interesting but take like an hour? We don't have the time to watch it. So basically with a chain of 5 models running sequence, it's speech recognition models, large language model, and voice clone TTS. Basically, we can allow the AI to do the video summary. We can condense the 1 hour audio's contents in 1 minute summary, also with the speaker's original voices.
So I think what we do at MyShell, basically we want to host as many as models possible for the creators to be able to easily orchestrating together the calling flow for the different models to change the input and output of different models together to build complicated and very useful AI applications in different kind of content category, either for entertainment or education or even personalized apps, and without any codings at all. Yes, so I think just talked a lot about the AI applications and the AI part. I think the interesting part for the AI application is the nature of modularity and composability of it. Because we all saw there's many part of it, because there's the AI models. All the models is not built by the creators building the applications. It's actually contributed by the open source community, or it's contributed by the individuals that's training the models, fine-tuning the models in different kind of categories, because people nowadays think there's only image generation and also large language models, but in reality, there's much more than that, like traditional computer vision models, processing images, and also the generative videos, and also GIFs, and many others. And also the agent frameworks really unified all the models together and keep things that stable and to work out in a more deterministic ways. And the modular UIs, just like the video summarizer I showed you guys, basically it's gonna take users' input in many fashions, either videos, images, audios, and others, and also renders all the generated results in a unified UI user interface. So why we need crypto? I think because of the modular nature and also the new ways for creator to build interactive application really makes the definition of developers more broader, because in traditional settings, the developer are the guys with the coding capabilities to write the code, to deliver the application that's posted on the Google App Play Store or the App Store. But in nowadays, anyone without coding experiences can leverage all the AI models to build the AI applications, which means there are gonna be 10 or 100 more developers out there. And also the modular nature of the AI application really needs a very flexible financial system to incentivize all the contributors, including the AI application creator and also all the model contributors. So in our setting, we designed tokenomics that's gonna incentivize all the participants, either the AI creators or anyone's contributing the popular models, or the people that can be the backers or the investor of the AI application or the models. So here's just one example. It's called SongMaker GPT. It's an application that's built by our creators, and we have the patron badge system, which basically, if you are not the AI guys and you don't know what the ideas or you don't know how to create AI content, you can still use the tokens to be the part of the owner of the AI application. So whenever the AI application is making the revenues, all the shareholder or the patron badge holder can also take a cut of it. So you can be the investor roles to participate in the whole ecosystem. So in this way, basically, we make all the AI application, all the AI models become AI assets that can be owned in fraction and also can be traded similar to DeFi. And we saw this page is more like a DeFi settings. There's even TVLs. Basically means all the people that's interested but not able to create the AI application, they can to own and invest part of the applications. And what if everything can also be on chain? From the usage to the model inference and also all the AI assets trading part. So basically, we have demonstrated early prototype working with Story Protocol and Retro that we can make all the AI model registry on Story Protocol's Explorer and all the model inference and the model response fully on chain. Yeah, everything is on Ethereum testnet. And also for the model, for the application composition, it's on the Story Protocol. And in second case, it's just simple image generation scenarios. All the generated image is hosted on Rwave, and also the AI derivation chain, which means this stable diffusion model generates this image. The relationship is also on chain. So we actually, given in these scenarios, we have a very strong value back towards all the AI assets for people to trade because all the usages, all the relationship of all the composition is recorded on chain, and all the inference is also on chain. Yeah, so that's summarize the topics I want to discuss today. I think the interesting part is really how the crypto gonna bootstrap the early creator economy. I think it's totally new creator economy in terms of the given the power of crypto and AI, because in previously we just don't have a such large scale and collaborative creator economy. It's just one people shooting the videos or posting the images. But nowadays, people can contribute the models, can use the models to build their own applications, can either be the backers of different models and AI assets. I think this gonna be really demonstrates the powerful of crypto, just as we saw in the DeFi summer, because everything is so modular, so composable. That's how it drives the innovations. So if any of you guys building the AI infrastructures, we are looking for partners to bring the AI on chain more efficiently. Yes, thank you guys. Yeah, is there any question? Basically, we focus more on the creator economy and also how to make the creators easily use all the AI models to build applications. But for the on-chain part, especially the verifiability, the decentralized compute, this kind of partners we are looking for. It's more on the infrastructure layer. Yeah. Like Rachel, they are providing the protocols to bring all those kind of decentralized facilities to make it on-chain registered and on-chain callable. Yeah. I think in a lot of events here, most of the projects building around the infrastructures, and we focus more on the consumer-facing side and also on the content ecosystem for the usages, especially to bring more concrete usages from the Web2 users to the Web3. Because I think in our scenario, the AI creator is the guy that's creating the assets. And the Web2 people is using the application, is creating the usage, and it's supporting value for the AI assets. And the crypto user is more getting used to trading or owning the assets. So that's how we are orchestrating all the different user profile together. Yeah. Yeah. I think it's actually the creators that they unite everything together, because there are millions of models out there on GitHub, on Hugging Face, and on any kind of places. And but also the model itself is not valuable because something without usage is not valuable at all. So it's a creator using the models, turn it into some use cases. It's just like how the application startups founders doing. Basically, they are not creating any new technologies. They are composing the existing technologies into a user-facing product that's providing value to the users. I think our creators serve similar roles as application founders. So they are the guys uniting all the models, and also the crypto user in this scenario is more like the VCs for the founders to be the backer of them. Yeah. Yeah, go ahead. Yeah. So I think current approach is more, because I think there are multiple ways to make it on-chain. The simplest setting is use the Oracle to just bring the inference result of the off-chain compute on-chain. That's the simplest. And in Rachel solution, basically they have an on-chain coordinator, because they are building a protocol that's gonna run on any kind of compute infrastructures, either decentralized or centralized ones. But still, it has all the nodes, the network of the node is decentralized in that settings. Basically, they are building a solution that's we run the node with our models. So, and also their on-chain coordinator knows which centralized server or which machine is running which models. So when user is sending the on-chain transactions, they're gonna include the input, the model they need. So the on-chain coordinator gonna knows where to send the off-chain compute actual device. So and also when the computation is finished, it's gonna post the result on chain, either with a verifiable proof or without it. Because nowadays generating a verifiable proof is so expensive. It's not justified in every single scenarios. So basically, probably it's gonna be more for trading oriented, but not for more entertainment and oriented, like chatting with your girlfriend. I mean, AI girlfriend. It doesn't need a verifiable proof. So I think they are providing these kind of solutions, and we are working closely with them to bring on-chain AI as many as possible. Yeah. Any others? All right, great. Thank you, guys.
one in the lobby. Just like flip it on so I can make an announcement. Yep. Hey everybody, we're going to get started with our next talk in 2 minutes from Autonomous/Olas. 2 minutes with Autonomous. You guys can come to the main stage when you get a chance for the next talk with Autonomous. We're going to get started in about 2 minutes. Thank you. Yes, please. Thank you.
Hey there, thanks for coming. So I'm David, co-founder and CEO of Valerie, and with me is Oak, co-founder and CPO of Valerie, and we'll be talking about Olas, and in particular about building autonomous agents on Olas. So for those of you who don't know what Olas is, let's find out. The tagline is Crypto's Ocean of Services, and that's because Olas enables anyone to create such services. We'll find out what they are in detail, but you could almost make an equivalence between them and autonomous agents. Olas breaks down into 3 parts: protocol, framework, and the ecosystem. So the protocol is deployed on-chain. In this case, Olas doesn't have its own chain. Instead, there are deployments on currently 8 chains. And the ambition is, and we're certainly in the process of deploying on every major EVM chain, and Solana is also already part of the mix. The framework is sort of the off-chain part of the stack. And it allows you to build these services. We'll learn more about that in a second. And then the ecosystem are basically all the people, obviously, who are contributing to it. Namely, there are sort of a couple of roles which people can take in the ecosystem, and we'll get to that as well. So a point of relevance, Olas has actually been doing autonomous agent for quite a while. So we started in 2021, late 2021 with Olas, and it then came in stages on-chain from summer 2022. And we just this week, no, I think on the weekend, hit a very exciting milestone, which is that Olas agents have now made more than 10% of all safe transactions ever on GNOS's chain. So, yay. So this idea that autonomous agents will become crypto's billionth and trillionth user, I mean, we're at the very beginning there, but it's realistic, I think. So what's an autonomous service? Well, there's a couple of things we want in autonomous agents, and I'll motivate that. So firstly, kind of by definition, we want them to be intelligent. That obviously can range anywhere from rules-based to kind of learning type agent architectures. We want them to be flexible. Flexible here can mean a lot of things, but certainly one element of flexible is being able to interact with ideally anything and everything. That means like off-chain APIs, on-chain smart contracts, and so on. And we want them to be crypto native. Now, crypto native, again, can mean a lot of things. And actually, the stack, we'll find out, lets you kind of define that, configure that almost. One thing which it means is just interact with blockchains, use them like an end user, make payments, contract with smart contracts, have programmatic on-chain interactions. But another thing is that of decentralization. And so autonomous services, we'll find out, are effectively autonomous agents which you can configure to be run as decentralized off-chain networks. Now, as a result, these autonomous services kind of combine features. It's obviously not replace. All these other technologies have their role, but they combine features which you can find in smart contracts, web services, and automation. So let's uncover the beast. It's a bit unfortunate that I have to always be so close to the microphone, but this is an abstract representation of an autonomous service where the service takes the form of a deployment with 6 nodes or agent instances, as we call it. So these cute little agents there are your agent instances, and they collectively form the autonomous service. So the autonomous service runs off-chain as a sovereign network, right? Yesterday, if you were here, we had quite a few presentations about AGI and how autonomous agents are sort of the path there. And what always came through again and again was the importance of these kind of systems being sovereign, because it's kind of in the name. If the autonomous agent doesn't have sovereignty over itself, if it sort of needs to be run by something else, then or poked by something else to even be autonomous, then that already reduces its autonomy. So therefore, in Olas land, each autonomous service is its own small off-chain network. And in this case, it's 6 agent instances. But the great thing the Olas stack allows you to do is you can run the exact same application as the 6 instance network. You can also run it as a 50 instance network, or you can run it as a 1 instance agent instance network, right? So it's basically just a single agent. And that's exciting for a couple of reasons. Firstly, if you think from a developer standpoint, you're not going to deploy your network on day one with a whole bunch of node operators. So it's very practical if you can run your agent initially just on localhost as like a single agent. And then sort of maybe you run it on localhost as like a distributed system with 4 agents. And then eventually, once your system is mature, you might decide to run it as a decentralized network where you have different operators, let's say in this case 6 of them, each operator running 1 node, like you would have in a blockchain network. And the use case for that, we have some in Olas and some outside. Olas DAO, for instance, has this product called Contribute. It's effectively allowing it to control or more like direct the social media hive mind of Olas by rewarding specific social media contributions, which are scored by this autonomous agent system. And in this case, the system is running as this off-chain network, and the Olas DAO actually owns it on-chain. Now, we also have these 2 bars here on the left. What are they trying to say? Well, on the left, we have this point being made that autonomous services can, by their nature, because they run off-chain, pull data from various places. So be it your centralized API, or be it just on a node of an existing network. And then they can act on one or multiple networks at the same time. So a given autonomous service can be deployed against a single network or it's against multiple and get its work done there. Why is the safe logo there? Specifically, we use account abstraction. So every single autonomous service basically has these off-chain nodes, each having a single key pair, and then you have on-chain the smart wallet, and effectively it looks a bit like a multisig. You have this off-chain autonomous service acting on this on-chain wallet. Now, a couple of final things on the architecture. So there's this infinity symbol. It's another important thing about autonomous agent which I like to make. In my mind, and certainly the whole team's mind, if you have an autonomous agent, it really only is truly autonomous if it's running all the time and sovereign. If it's basically a smart contract, which certainly has its role as an architecture, which requires to be poked by basically being transacted upon all the time, I would think that definitely has a tremendous amount of use cases, but I personally wouldn't call it as an autonomous agent, because in my mind it's not capable of taking action by itself, and that is one of the key definitions of an autonomous agent, is being able to act when you want to, not when you're just being transacted upon. So by now you're probably all converted, but no. If you have any questions about the architecture, please reach out and we can help you further. Just to give you an idea of what can be built and has been built. So I mentioned Olas Contribute here on the bottom. That's this product where effectively community members get ranked with a large language model off-chain by this autonomous agent system on their social media contributions. And the DAO can adjust over time what kind of engagement it wants to foster. L-Collector is an example in the NFT space where an autonomous service basically acts almost like a collector of NFTs and continuously, kind of based on some preferences it has encoded, kind of goes around and collects them. Autonomous Fund is more on the DeFi side, where this actually specifically works with Balancer under the hood. So Balancer has this concept of a smart managed pool. A smart managed pool is like your average, like your run-of-the-mill pool, except that you can adjust the weights dynamically over time. And so what this then means is if you have this off-chain autonomous service owning this on-chain smart managed pool, it can like be basically a complex oracle to this pool and adjust these parameters as it wants to, and then by the nature of people trading on Balancer, this pool will sort of reflect that index. So you basically can build index products and things like that. It's also an interesting application of DAO treasury management, by the way. So you could imagine like plugging that into Contribute and sort of having a feedback loop between that. Automation, I'll skip because it's kind of obvious the use case. Oracle is also pretty obvious. There's very interesting, more sort of fully on AI-focused use cases. One is that of the governator. So we heard that a couple times yesterday as well, this idea that you have basically DAO decision-making being sort of encoded in an autonomous agent and it then running continuously and on behalf of the DAO. Well, that's a reality here in an autonomous service already. We built that actually last year at ETH Denver. Oak and I had a lot of fun because if we think back about what was discussed yesterday, one of the challenges with building these kind of systems is that you ultimately going to use some forms of large language models under the hood. And one big challenge here is sort of your model being poisoned. Another one is being, even if your model is correct, it might hallucinate. And actually, one of the big benefits of this architectural approach is that you can basically build an autonomous service which uses many different models, pools, comes to consensus off-chain on what these models tell it to do next or how to interpret a certain proposal, and only then take action either on snapshot or on chain. Prediction agents is actually the biggest use case. That's the one which drives probably to about 90% that metric we saw earlier. There's 3 types of different agents, and I'll let Oak talk about that.
So we'll get more into the, okay. Can I take this out? I just move it around a bit. Nice. So we'll talk specifically about prediction agents. That was the last service that David came to. But yeah, I'm basically going to be moving on to the section about like what you can actually build at the hackathon, or in general with the stack. And become an Olas builder, if you like. Actually, just out of curiosity, I mean, this is a hackathon, but like, how many devs do we have in the audience here? All right, nice. Okay, so David just mentioned the prediction agent service, and as he said, there are multiple different agents who contribute to this service. The output of this service is predictions. It's basically. There are, it says three types of agents. So one will listen to new prediction requests and make sort of deploy prediction markets on chain. The second one will actually watch for those markets, research them, and place bets in those prediction markets. And then the third one will answer the markets, sort of arbitrate them. The betting one is probably the most relevant one for us to talk about, and it's sort of the biggest focus of what we have bounties for at the hackathon. So I'll just go through that quickly. So you can see at the top, first thing which happens is that the agent will look, watch for new prediction markets. So it's very focused on current events currently. Obviously, it can expand later, but that's what it's focused on today. And so your agent, if you're running one, and there are many out there running already today, will see a new market being created on NOUS chain on the Omen protocol. It will then use AI tools to get a probability and a confidence score. So the agent uses this tool called Olas, which is an AI tool marketplace. If anybody has questions later, we can go into like exactly how that works. And so the agent will pay a bit of money on chain and basically in response get a probability and confidence score level back. And then next, it will use that probability and confidence level to participate in the prediction market directly, and potentially it will receive some earnings if it does well. Those two at the bottom should actually say prediction market, of course. So that's the sort of the overall setup of these prediction markets. And as I say, like the bounties that we've got is pretty focused on this. So moving on directly to the bounties, we recently released this site. You can go to it at build.olas.network. And what we've aimed to do here is like make it super simple for people to know exactly what to build. You can see that each of these has rewards available that are like completely separate from the bounties. And again, maybe that's something we can go into more detail about, but suffice to say, the Olas protocol rewards developers for contributing useful code, or it's designed to rather. So the first bounty is to create a MEX tool for prediction agents to use. So again, MEX tools are these AI tools which these prediction agents can use to sort of inform, to basically research questions and come up with a probability. So what you'll do here is if you want to build this at the hackathon or otherwise, you can go review all of the existing MEX tools. There's a repo there. You can take a look into them. You can then implement a new tool. It's fairly straightforward. It's more or less a simple Python script. Thirdly, you can use a benchmarking tool, which we've developed to sort of understand like how accurate the tool that you actually build is. And then finally, there are a few steps that you go through in order to get your PR. Basically, you open a PR to have the tool reviewed, and then follow a few steps that can ultimately lead to earning build rewards. But most relevantly here is that if your tool does perform well on the benchmark, and it's in the top 3 at the hackathon, then you'll be eligible to win a 500 USDC reward. Yeah, worth noting that the tool does need to be minted on chain via the protocol. And if you need help with that, then, or with any of this, then please do come and find us. The second thing that you can build, and this has a single bounty available for it, is a trading strategy. So the MEX tool is actually sort of the AI tool which researches a prediction market, whereas a trading strategy is obviously a strategy that the agent uses in order to decide when and how to participate in the prediction market itself. So again, the simple process is to review the existing strategies, come up with an idea that will outperform those, or will take another useful route. And then similarly again, open a PR, mint it on chain, and submit it in the hackathon. The final option that you've got is, and there's a slightly bigger reward here because it does sort of require a little bit more, I don't know, it's not quite as straightforward as the other ones, is to sort of come up with an entire agent or an entire autonomous service yourself. So, I mean, David went through all of the services that we've got. We missed it, but there's actually a section for kits, which is sort of like, like a set of templates which you can use to directly boot things up. And you can go through it, but that could be a good place to start. And in order to get access to this bounty, you'll need to develop a full service, mint it on chain, and then have that service perform at least one transaction on chain. I think that's it. So yeah, that was an overview to Olas, and also an overview to what you can build in this hackathon.
I'll just say one extra thought, which I just had. I think a couple of the protocols who are also sponsoring are quite composable with our bounties. So for instance, if you build a Mac tool, as Oak was saying, you would effectively write this Python script where you might use various large language models, various other APIs, various other technologies. You could, for instance, use a model deployed on one of those providers who are also sponsoring, or you could maybe even look into, like, is there some kind of verifiable approaches to some part of that compute? So there's a lot of, I think, composable ways of doing that where you can sort of max your bounty take home, so to speak. And for those watching online and anyone after the in-person thing, we also have a Discord which is manned at working hours, but like we're very active in it, and we have all the kind of team members, engineers there as well, who are happy to answer any technical questions. Thanks.
Great, we're gonna have about a 5-minute break and wait for the next speaker to come up. So just stick around or get some food. Thanks. Yep, oh yeah, okay, great, awesome. Shoot, we're gonna wait like 8 minutes or so, just to start on time. Yep. Did you send them to Darren? Oh, we have them. Yep, we have them. Oyster. Yep. Oyster TE. Yep. Sweet. Thank you. And how do I want to pronounce your name right? Isil? Esli. Okay. Yeah. ESLI. Okay, yeah, that's okay. I had an IL. Perfect. Perfect. Yeah, we're going to start our next session at 1 p.m. That's about 7 minutes from now with Esli from Marlin. Again, starting about 6 minutes. Thank you. into the mic. Do you want to hold the mic, or do you want the mic to be here? Yeah, it's fine. Okay, great. Just want to make sure it's like good size. Might be a little too high. Perfect.
Sure. Yep.
And then you got your clicker. Take your time. You have
Yeah.
plenty of time.
Yeah.
That's pretty much it.
Yeah.
Any questions?
No, that's it. Thanks, Thanks, Marcus.
Hey guys, we're going to get started with Marlon's presentation. So if you want to come into the main stage, we would love to have you. Come sit up front. We don't bite. See you soon.
Good to go. Yep. Cool. Let's get started. Hi everyone. I'm Asli. I'm from Marlon. What we are building is a trustless coprocessor that can be used for multiple use cases. So without further ado, let's get started. So the first thing that we want to talk about in this whole hackathon event is what is a coprocessor? Why do we need it, right? That is the first thing that we want to touch upon. The second thing is, how would you choose a coprocessor? There are multiple kinds of coprocessors out there. And then we will dig a bit deeper into Oyster, which is the Marlin's coprocessor. Then we'll touch upon the bounties, resources, and any support that we offer. Okay, so let's get started. What is a coprocessor? Why do we need one, right? So a coprocessor at a high level is nothing but think of it as an additional machine that helps you to generate more compute power, right? And why is it useful? Because A, it will unlock a lot of capabilities that you won't be able to do it otherwise. Think of your phone, which used to have a single chip, right? And for a long period of time, we were able to do very small activities. But with the invention of new additional chips, now we are able to do much more advanced systems, right? So think of your coprocessor in a similar way, which will unlock new capabilities, and they also make some of your systems cheaper. Some of them might be performance oriented and will also unlock a lot of new capabilities, right? And pretty much they are upgradable, right? They have very little to no prerequisites if you want to scale them linearly. Now, just jumping to the next one, we defined what a coprocessor is. Now we want to discuss why do we need one, right? We're happy with the way things are, right? Why do we need one? Because A, we were actually not happy with the way things were, right? Especially in case of blockchain, the L1s are super expensive. It's close to impossible to run heavy workload complex tasks, right? And then second thing is, you may debate that, okay, L2s are here for that, but ultimately L2s are also smart contracts. They also have limitations, right? That's where coprocessors comes into picture. They help you with bunch of opening up a lot of possibilities and opportunities. Some of them being, you should be able to access data from archival blockchain data, right? You should be able to access Web2 data. You should be able to pass on to Web2 APIs, whatever that you have built in, right? And then you should be able to run long-lasting servers, right? It's not a point in time only, but you can also run something like your websites, you can host them. So yeah, all of those possibilities. And the important thing is coprocessors are generally circuit agnostic. That means as a developer, what we care about is we don't want to learn a new language just because there is a requirement, right? So you want to build on top of what you are familiar with. You just want to tweak a bit here and there, but you don't want to sit and relearn the whole flywheel again, right? So hence coprocessors, right? Now jumping directly into the different kinds of coprocessors. So these are the three kinds of coprocessors that exist in the market today. So you have zKML, you have TEML, you have OPML. In terms of speed, we have seen that both TEML and OPML are fast. zKMLs are in general slow, depending on the compute that you have been executing. In terms of confidentiality, Ts offer both model as well as your private inputs, right? Given that it's a secure enclave, everything is a black box out. So no one is able to access what is happening inside. Versus in zKML, you do have an option, but either you can make your model private or you can make your inputs private, not both. And in case of OPML, it's generally everything is public, right? And in terms of finality, TML is immediate, zKML is also immediate, but OPML generally have a 7-day contesting period, right? There has been debates that, okay, we can reduce this further, but yeah, again, the finality is not instant. Imagine you trying to do some P2P payments. You can't wait for not even 10 minutes, right? You want all of this to be pretty much instant, right? And then in terms of price overhead, this is where TML actually shines a lot. It's anywhere between 10 to 50% higher compared to your traditional compute, versus on the OPML side, it's about 500%, and on the zKML, it is 10,000%. Just because the kind of compute that is required, the cryptographic security that is required, it's super expensive. And on OPML side, it's expensive because there is a whole fisherman concept. Someone needs to check and verify whether everything is, whatever is submitted to on-chain, is it true or not, right? But in case of TML, you don't have to do any of this, right? I hope everyone knows what a TE is. TE is a trusted execution environment. Think of it as a secure enclave. The generic examples are Intel SGX or AWS Nitro enclaves, and NVIDIA confidential computing. So yeah, just to name a few. In terms of security, TML offers a hardware-based security. That means you are trusting the hardware provider itself in terms of Intel, AMD, or your AWS or NVIDIA. So that's one limitation, whereas in zKML, it's totally cryptographic. So you know that whatever the ZK proof has been generated, you can be rest assured that it has been done the right way. And in terms of OPML, like we spoke earlier, it's a concept of fisherman plus cryptography. And in terms of suitability, where is TML suitable for? TML is suitable for all kinds of models, be it small, large. Fun fact, we are able to run Llama 2 and Mistral on TML, right? So zKML, at this point, the way it is, it's only suitable for smaller models. Probably you can run a tiny Llama maybe, but yeah, no one has tested it yet, right? And in terms of OPML, it's pretty much dependent on how the protocol has designed the proof, the fraud, and the proof of design, right? So yeah, moving on, introducing Oyster. So far we have covered what is a coprocessor, why do we need one, and we also benchmark different kind of coprocessors. And based on this, we realized that TML is the way forward and will be useful for about 80% of the use cases, right? Not saying that the rest won't be useful, but they are for very specific use cases, but TML is one of the approaches which can be used for about 80% of the instances. So yeah, introducing Oyster, a TML-based coprocessor. So what does Oyster does, right? It's a decentralized node of operators. So everything, any compute that you are offloading on off-chain, it is being executed by a decentralized node of operators. Then we do have all of DevOps tools inbuilt, right? You don't have to do anything, right? For example, auto-scaling, fault tolerance, all of those things are inbuilt. Web2 applications can also directly use Oyster. Think of it as a supplement to your AWS or GCP. And you can work with any language. Like I said earlier, these are pretty much circuit agnostic. If you are a developer who prefers writing code in Rust, just do it, right? You don't have to relearn and do things, right? And yeah, you can access Web2 APIs. And right now, Oyster is deployed on both Arbitrum and Polygon. But yeah, we are pretty much chain agnostic as well. We can pretty much scale to all the chains, and we are circuit agnostic as well. So yeah, some features of TEs that we spoke about. What does this TEs entail? These are secure enclaves. They provide hardware level isolation and memory encryption, so that even the host machine where the code is running, they won't be able to access any of the code. That's one. And second thing is, Encryption is possible at both storage as well as network level, while compute and also while in rest, you would be able to encrypt information. And third thing is it's pretty widely available, right? So and easily scalable as well. You have providers from Intel, AMD, NVIDIA. So they are cheap, fast, and infinitely more scalable. So how Oyster works. So in case of Oysters, we have two approaches. One is a serverless approach and one is a server-based approach or an instance-based approach. In case of serverless, you don't have to rent an instance or do anything. You can directly use the functions without you have to renting an instance. The only limitation though it's based on WASM or JavaScript at this point. However, on instance side of things, everything is possible, right? You literally take your code, you package it as an enclave, and then you make it public on any IPS or a decentralized storage, and then you pretty much deploy it, right? So it's pretty straightforward in terms of using Oyster. Irrespective of whatever code you have, all you have to do is you have to build it into an enclave. We have tutorial available for it. We also have tutorial in terms of how our team was able to run the whole Llama 2 inside an Oyster, what are the limitations that we have faced during that. But yeah, for this hackathon, we'll be limiting the whole approach towards instance-based only for simplicity. But yeah, you are happy to explore other approach of serverless as well. How to access? Like I said, there are both options available via smart contracts as well as Web2 APIs. Via smart contracts, you just relay your request to our Oyster network, and then Oyster executes and send it back to your smart contract so that you can verify it on-chain. So everything is, the compute is happening off-chain, but the verification is happening on-chain, right? So that's one. And for Web2, it's pretty similar. You don't even have to do a lot of shebang like we did with smart contracts. You can directly deploy a Node.js server. We do have a tutorial available. Or if you want to do a image build of your AI model or whatever, you can still do it, right? So build with Oysters. This is one of the exciting things. So yeah, what are we looking for, right? Any top two LLM-based applications. So we will be providing instances with both Llama 2 and Mistral being available. So yeah, you can just access that and build application layer on top of it. That's one. Second is any two DeFi applications. Again, the instances will be made available with Llama 2 and Mistral being available. You have to build on top of it. So yeah, auto contract execution when it comes to DAOs or governance. That is another thing that we are looking for. Best social application. If you are building a social engine, recommendation engine, yeah, you can do that as well. So the fifth one is a creative application, NFT, or anything that you want to do on the creative AI side. Yeah, that is also something that we are looking for. And finally, if you want to build and deploy your own AI model, as in you have your own AI model and you want to make it private and keep it secure, you should be able to do so, right? So the model weights and everything is pretty much private to anyone outside of the enclave except you, right? So yeah, these are the 6 different streams. My recommendation is whatever you are building, just deploy it on Oyster, right? Because it's pretty much whatever you are building, think of us as a equivalent to an AWS, but much more secure. So you have Ts and everything. So whatever application that you are building, my recommendation is just to optimize for your bounties, just deploy it on Oyster. Yeah, Ahmed. Feel free to do everything, right? I mean, we are not restricting at this point, but yeah, we just want folks to participate and explore the platform. So yeah. Resources to build. This is something you would want to know. So we have our docs, everything is up to date. You can just head over to docs.modulin.org. There is a section for Oyster. You will find all the tutorials within instances, how to deploy Llama and everything. So yeah, and then instances like I mentioned, you have Llama and Mistral pre-deployed, will be made available to you. You can build on top of it. Then tutorials is also part of our whole doc section, wherein you can see how folks have deployed a JS server or how folks have deployed a Llama. In terms of support, our Discord is pretty active. We do have created a dedicated channel for hackathon. Head over there, post your queries. Team is pretty much active to support. And also our Telegram is also super active. So yeah, just head over to either of the channels, ask your questions. We are happy to help. And yeah, I'm also here. So yeah, if you want anything specific, happy to answer those. So yeah, that's it. We are Marlin. We are building the Trustless Coprocessor. Cool. Thank you. Thanks, everyone. Yeah. Yeah, we have. Sorry? So we do have a remote attestation. So whenever a code executes inside an enclave, you get a remote attestation which says that this specific code has been run inside an enclave. So yeah, that is available. And then you can take that verification, you can take the result along with the remote attestation, and then you go back to on-chain and verify whether it's the right thing or not. So yeah. Cool. Any other questions? Nope. You're good? So anyone who wants to decentralize their infrastructure, they can work with us. And anyone who wants to build complex tasks or complex problems, they can use Oyster. So yeah, anything pretty much about complexity and also decentralization, that's where we come into picture. For example, if there is a DAO which don't want to manage the whole website themselves, they can just put it on Oyster and ensure that everything is decentralized and taken care of, right? And given that you are building the enclave image, it ensures that there is no tamper-proof, right? No, it's pretty much impossible to decrypt an enclave image, right? Actually, a few other use cases of Oyster were, we were able to build the whole decentralized gateways for Bonfida, similar to eat.limo. We also have Bonfida, and also we built the same thing for Space ID as well, right? So decentralized gateways is one of a prominent use case. Decentralized front ends, you have a website, you pack it, and you just put it out, so that you don't have to manage the whole DevOps aspect of it, right? Or you want your DAO to manage your website, you just create an enclave image and you put it out there, right? And when it comes to AI applications, it's totally up to your own imagination, right? Given that Oyster can pretty much handle heavy computations, you can, it's totally up to you what you can want to build, right? Some of the cool things that folks have built is a private prompt as a topic. So if you are a user and you care pretty much about your privacy and you don't want anyone to look into your prompts, you can ensure that the encryption happens at the source, and the final result that you get is also encrypted, and you need to decrypt it, right? Pretty good use case for healthcare, in my opinion, because there you are working with very sensitive data. So yeah, that can be one of the things. Even for financial models, right? Say, Cameron, you have a pretty slick strategy which you don't want anyone to be aware of. You can pack it and put it in an Oyster, and when the time arrives, it will just trigger a smart contract and everything gets executed. And everything is in a black box, right? Only you are the only person who knows what you have set it to be. So yeah, and in AI, like I said, you can develop your own models, you can deploy them on Oyster. So yeah, yes. So it's not a GPU, it's a CPU only, but we were able to run Llama 2 and Mistral with that, and very little to no latency. And in terms of GPUs, we are not there yet, but yeah, we are in the process of procuring GPUs. Sorry? No, not exactly. I mean, we were able to run Llama 2, the 7B model, and we were able to do everything as it is. There are a couple of smaller restrictions, workarounds. So, for example, the enclave image can't be beyond 1 GB, right? So there is a way to work around that, which is made available in our docs. So yeah. Cool. Yeah. Yeah, go for it. Sorry? We are quite a small and decentralized team. I mean, we are about what, 12 to 15 folks, pretty much decentralized, spread across Asia, North America at this point. So we were part of the Binance Accelerator season 2. So yeah, been around the block for some time. So yeah, and we are also backed by Electric Capital. Yeah. No, it's a DAO. It's not like, I mean, there's a foundation that takes care of everything. So, I mean, it's not only, I mean, the foundation is the central entity which ensures that the funds are not being misused and everything is happening the way it's supposed to be. Yep. Cool. Thank you. Thanks a lot. Thank you.
Great. And up next, we have Michael from Zero Gravity. We're going to wait about 8 minutes or so until his session gets started. So feel free to hang out and see you in about 8 minutes. Thank you.
gives me a bit of time to go to the restroom too.
Totally. I'm just going to set it down. When you pick it up, it's live, so just pick it up very gently.
Michael, do you just come, just want to make sure the mic is sized up. Great. Do you want to hold it, or do you want to?
I would love to walk around with it, actually, if it's possible.
It is wired, so just be wary. Cool. Here you go.
It works.
And I'm assuming you could probably introduce yourself a little bit better than I can introduce you. But
Sure.
yeah, cool. Camera's always running. We're going to edit everything after. So
Okay.
awesome.
Okay. Could I get my slides? Good. Well, super excited to see all of you here. This is the first time I'm giving this presentation, so you're getting all the alpha for the first time, and so you can front on everybody. But super excited to present 0G. It's the first modular AI chain, and we're focused initially on an infinitely scalable, programmable data availability layer so that true high-performance applications can actually be run on chain. And so I'll unpack a lot of that as we go along. But first, let me just introduce the team a little bit. So you've got myself. I started out on the technology side, started at Microsoft doing software development and technical product management, and then switched over more to the business side. Worked at Bain & Company, worked at Bridgewater Associates and TradFi, and then started my first Web2 company, scaled out to 650 people, raised a bunch of venture financing, became a unicorn, top YC company, and so on. But went to a board chair role and left that for Web3 because I'm just having a lot more fun in Web3. And I've actually invested in my first Bitcoin in 2013, did a bunch of ICOs, and then more recently like WorldCoin and Uniswap and so on. So love reading white papers, and super excited about now actually being an operator in this space. The reason I actually did it as well is because I met Ming and Fun through Thomas. Thomas is my grad school friend from Stanford. And he basically said, hey, I invested in this project called Conflux like 5 years ago, know the founders super well. You guys should link up. I think you'd do super well together as a team. Met up with these guys after 5 months of co-founder dating, basically determined that these are the best engineers and computer scientists I've ever worked with, and said, we have to build something together. Like it's the time, this is amazing. So just to give you a sense, Ming has been at Microsoft Research for 11 years, basically wrote a lot of top papers in distributed storage, like Tango and Curfew. He also wrote some of the first AI algorithms for Microsoft Bing. And then Fun was actually his intern at Microsoft Research, and that's how they met. And Fun, he was part of Andrew Yao's class at Tsinghua. Andrew Yao's like a Turing Award winner, and then met Ming, and then started doing his PhD at MIT, and kind of worked on Conflux right after he finished that, and became a professor at UToronto as well. Holds 2 Olympic gold medals in informatics, so I never want to challenge him to a coding contest. I definitely will lose, but so really passionate about the team, super fun dynamics. We laugh a lot. We love to build things. We played, so Hack is one of our lead investors, and they recommended like, hey, you should check out this game called Paddle. So we played Paddle together for our offsite, and it's like the super weird game. It's like tennis, except it's like squash, except it's like racquetball. And so it's like a bunch of things combined, but it was super fun. So we have a lot of fun together. And so really feel fortunate to have amazing investors. Our seed was 15x oversubscribed because of what we're doing. Delphi, one of our investors, thank you for being here. Nice to have you here. Obviously, really great people, Manklas, Hack, Gumi, many great companies that are part of the mix, and so super exciting to have them be on the journey with us. And so I mentioned this a little bit briefly, but basically experts on blockchain scalability, on AI, on distributed systems and storage, and so I've done a lot of research papers in this space, and are really excited about really implementing that research into production very, very rapidly as well. And so what is the core problem that we're solving? So this is something that we took a very first principles approach to. We were fundamentally thinking about what does Web3 scalability end up being? How do we get to Web2 parity, both from a performance perspective, but also from a pricing perspective? And so that was the first line of thinking. Because if we don't get there, how do we build true high-performance applications? How do you build on-chain gaming when you can't manage state, when you have state explosion? How do you build on-chain AI applications when you need a huge data availability pipeline in the gigabytes and that's not available? And so that was really our first thinking. And then the real key impact is that if you have n rollups over however many transactions per second, you need very large data availability space in order to actually build that. And so we basically set out on a journey to say, how do we actually make this possible? For example, I spoke to a project the other day, Manifold AI. They said, we want to do decentralized training. And I asked them, like, what kind of data pipeline do you need? And they were like, yeah, 50 to 100 gigabytes per second should do it. And so we're like, we're up for the challenge. We can make this happen. And so those were some of the conversations and thoughts that we essentially went through. And so one of the key use cases that we're supporting in partnership with Aura and Modulus Labs as well is something called OPML and zKML. So for OPML, first you need to actually store the model on chain. And that can be very large, tens of gigabytes with the latest Llama model, even hundreds of gigabytes in some cases. And then you need to serve the decentralized inference traces. So if you want millions of concurrent users, you're dealing with gigabytes per second in data availability speed. No DA system today is able to handle any of that. So how do we build a DA system for the future so that we enable this type of application? The second example that's pretty interesting is, so imagine you're trying to scale poker, online poker. Let's say you have 100 million users, which in kind of Web2 world is actually not a lot. There's hundreds of millions of users. But you're starting to see that even there's just 3% saving and loading state, you're ending up with 120,000 gigabyte per day. Like, which DA layer manages that today? And so this problem is already real. So we've just recently chatted with somebody that works with DeFi Kingdoms. They have only 20,000 daily active users, but they're already managing a state of 14 terabytes. They're consistently running out of space. They're having issues. This is like a big, big issue for them. So how do we solve that? And there's many other use cases that need very large DA pipelines, so high-frequency DeFi, for example. Because in that use case, if you have a market maker, for example, and they're doing thousands, if not tens of thousands of trades a second, if the transaction cost just goes up by 20, 30, 50, 100%, their business model blows out. So how do you make sure that the transactions per second are consistently available and the cost is also consistent as well over time? Data marketplaces, zk proving, decentralized IDs, RWAs with lots of metadata, all of that will require very large data pipelines. And so how do we do it? So this is the core architecture. So we start over here with essentially a DA blob that gets split apart into erasure-coded data chunks through a dispersed server. And we hyper-optimize that as well. We can talk about that later. So that gets then put onto this storage network. And we built a complete storage network from scratch. And so we support all Web2 data types in this. You can completely customize it, whatever the replication that you want, whatever the storage location is that you want, however, what the data persistence is that you want, we can basically customize all of it. But these chunks then get split across some of the nodes on the data storage network, not all of the nodes. And so that then creates an aspect of horizontal scalability from a node perspective. And so as that is happening, we're also doing validity proofs in KZG commits to basically prove the validity of encoding with a separate consensus layer. Now, instead of using light clients, this consensus layer also does the data availability sampling, lots of nodes independently. Once they reach consensus that the data availability sampling is done, you're basically then writing a zk proof to the underlying L1 saying that, yes, this block is actually available. And then there's also some management of incentives, basically storage rewards and the storage proofs as well. So that's the core architecture, and that's how we're able to drive a per node speed of about 10 megabytes per second. And then with horizontal scalability, our consensus layer should handle about 5,000 nodes or so. So you're dealing with about 50 gigabytes per second per consensus layer. And so what does that mean? Like if you compare ourselves to anything else that's available today, like on ETH, you're getting 0.08 megabytes per second. So horrendously slow, very slow data throughput, makes things super expensive. L2, a little bit better. Dank sharding starting to get better. You've got Celestia, Eigen starting to get better. Then you've got Solana Firedancer at 1.2 gigabytes per second. And then a huge uptake for truly high performance applications. And then we look at the cost perspective as well. You've got alt DAs costing about 13,000 or so per gigabyte per month. Some other ones that are a bit cheaper. And then you start going to Web2 speeds. You've got AWS SDs, AWS S3 with SSDs, and AWS S3 without SSDs. And then you've got us. So with this pricing, we finally get to Web2 parity in terms of pricing and performance. And so that's super exciting. It'll open completely new application spaces. And so we also don't want to stop there. We're also introducing the first programmable data availability layer. So what does that mean? So what you can do essentially is you can save a state through a smart contract, and we handle the rest. So if you wanted to, for example, as a gamer, use Arbitrum and say, okay, I want to save my game state, and I'm running out of gas fees, I'm going to Polygon, you can load your state again, and then keep playing, for example. So lots of cool stuff can be done with this, and completely program it. I won't go too much on the details, because the concept's pretty straightforward, but we can chat about more if you have questions. So the other thing that we're introducing that we're super excited about is this concept of infinitely scalable DA. Because what we found out in our research is that not only does the node network scale, but you can also scale the consensus networks. And this is possible because we have a completely separate data storage network. So each one of these consensus layers can interact with the storage network at the same time. And then all of the gas tokens essentially are mapped to one overall ERC20 token. And the entire network is then secured via restaking. And we can do that through EigenLayer and Babylon and other providers as well. And so this is super exciting. Infinite data pipeline. And the other thing that's possible is you can actually dedicate individual consensus layers to a specific chain. And so now you can basically count on DA pipeline. So if you're a high-frequency DeFi provider or somebody like Layer N, for example, you can guarantee to your users that your gas costs will not rise because you have complete DA pipeline only to yourself. And so the other thing that we're introducing that we're super excited about is this concept of aggregated DA. So with this, what we can basically do is we can take a data blob and then aggregate all of the different DA layers, Celestia, EigenLayer, and so on. And then you can choose, as the end user, do I want to run this in high performance mode? Do I want high security mode? Do I want do I want a backup DA? So you could have a primary DA and a backup DA, for example, and kind of choose your configuration, if you will. And so super excited about this. So what does this allow? 100% uptime. Allows for load balancing. Allows for really loading and saving state to anywhere, NEO1, NEO2. And it's really great. It's a collaborative spirit. That's why I'm in Web3, because I don't think there's like true competitors in Web3. So it's super fun. And so this is my attempt at putting a very nerdy dad joke on the slide. So if you're not laughing, I know it's not working. So basically, the idea is that if you have an infinite consensus, you're adding a storage layer, and you're adding aggregation, that it's like modularity squared. And so anyways, so basically, you have maximum performance on-chain AI and gaming as part of that modularity squared. So you guys can give me feedback. If this is not funny, I will take it off the slide. So maybe after in the questions. Okay, so back to the AI use case. So where do we play? Some people might ask, like, well, do you support decentralized inference networks and so on? Of course we do that, but we partner with others to do that. What we do is really provide the data availability infrastructure, we provide the model storage, and then the execution piece is done through partners. And I'll go to the partners in a second. So we've got, on the execution side, we now support things like AI agents, autonomous smart contracts, zKML, and so on. And so here are some of the partners that we're doing it with. So for example, Aura does OPML. As I mentioned, you store the model on chain, and then we support the decentralized inference traces. Modulus Labs does zKML, so the use case there is a little bit different. You store the data used for the kind of compute on chain, so it's publicly verifiable. Because you can verify the compute, but you can't easily verify the data that was used for the compute. And so it can even store your training data and so on chain. And definitely making a strong push kind of in the AI side, but also making sure that we're supporting really strong layer 1s and layer 2s as we're building, and then of course distribution through some of the roll-up as a service providers. And so this is the first time I'm also sharing our timeline in terms of how we're going to execute. So public testnet is happening in 2 weeks. So be ready for that. We're starting to put documentation online. Private testnet tests have been going really well. And so stay tuned for that. Mainnet phase 1, end of Q2. And then mainnet phase 2, planning for end of Q4. So those are the key milestones for us. And then the key features that we'll have are, first of all, the infinitely scalable DA piece. Then we'll move on to actually implementing dedicated DA, aggregated DA, and then also doing things like programmability and restaking, and doing kind of deeper AI model support once we get to 2025. And then many different pieces on the roadmap for the community as well. And so how do you get involved? So definitely join our social channels. We'd love to hear from you in terms of what you want to build at the intersection of Web3 and AI. Also, our draft Gitbook is online, so take a look at that. Give us some feedback before it goes, fully live with the public mainnet. And then we also have a bounty. So we will pick the 10 best tweets where you share about what the application spaces are that you want to explore at the intersection of Web3 and AI. And we'll do the same thing for the top 10 blog articles that you write as well, where you talk about what you want to build at the intersection of Web3 and AI. So super excited to be a sponsor here. So thanks everyone for definitely being a part of this and enabling this great space for builders and the community. And so that's basically it. You can follow me on X as well. You can reach me via email. I don't know if that's easily visible from where you are. My TG, Captain Von Kirk. You can probably tell I'm a Star Trek fan based on that handle. And yeah, my X and our website. So thank you. Okay, real feedback. Was the joke funny? It's okay. All right, good. Thank you. All right. So vote of hands. Take it off the slides. Anybody wants me to take it off the slides, like that particular joke? It's fine. Okay. Leave it. Thanks. I love that. Love the love. Sorry? Yes. Yeah. We're planning on releasing a token as well. Yeah. We're planning to hopefully have exchange listings before during Q3. Yeah. Still determining the exact date, but before then, yeah. Yeah.
Hey, Michael, just thinking through the poker example, if you have a large on-chain model running that poker site, and crypto people are worried about their money getting stolen, what type of security guarantees take place here at Zero Gravity?
That's a really interesting question. You probably have to have an AI agent actually monitor the security as well. So we could build that in from a security standpoint. And then the consensus nodes themselves are secured through restaking, and so we can buy quite a bit of economic security that way. So I think those two specific things, and then can always monitor for kind of DDoS attacks and those types of things as well. Yeah, yeah. Yeah. So we're planning on doing a point system, so incentivized kind of testnet and so on, and then Because we're working with a lot of infrastructure providers like layer 2s and layer 1s. Through there, we will get application developers on top. And then we're also getting a lot of organic traction already from projects coming in and saying, hey, I want to build on this AIDA because I'm writing a game and it's using an LLM to generate the world, and I just want my model storage to be with you and then also have the inference traces served by you as a result. And so it's an all-in-one package. And so that's a perfect use case. There would be a roll-up, essentially. And then through the RAS providers as well. I think those are kind of the key ones. Anybody can join, yeah, it's trustless. Yeah, it's fully decentralized, trustless storage node. And you can decide as a node operator if you want to just run a storage node or if you want to run the storage and the validators. Could be one machine, multiple machines, really up to you. The goal for us is to use commodity server hardware. So I think right now we're looking at minimum requirements of probably 8-core CPU, 16 gigs RAM, like a terabyte SSD, something like that. We are hiring and bringing on board AI experts, so potentially, but not exactly sure yet on that. We probably work with our partners on that, like through like Exhibits or like IONET or somebody like that. Yeah.
Hey, Michael, what other sort of stakeholders do you have to incentivize here? Storage nodes, I think you said consensus nodes.
Yeah, validators, yeah. Yeah. I mean, it could be all in one machine, or same providers can do both, essentially. Yeah, so just different rewards. Once more the storage reward, once more the consensus kind of reward, yeah.
It'll be funny if starts using you guys to reverse the flow.
I was just chatting to the founder this morning, so yes, very possible. Cool. Other questions? All right. Well, thanks for listening.
Yeah, yeah.
Yep, we're good. Yep, tested. Great. Sweet. Awesome.
Thank you.
Thank you.
And just FYI, goal of this is to create read content. So just make sure.
Yeah. It's kind of like it's letting people know. Yeah. Yo, hi everyone. How's your hack goes today? We have a lot of people have talked about the AI times crypto, and today I'm going to share how you can actually build an AI-powered D app here. So I'm Cartin. I'm the co-founder of Aura Protocol. We enable AI on all blockchain. So AI has become like so powerful today. Like since the neuron structure come out to 2006, and then we have some sort of like a AGI now today. The large language model help us every day. I pretty much use ChatGPT every day now. And so such important thing, technology. How can we bring it to the blockchain? And blockchain we need that, right? Because like the smart contract now they have really limited computation ability, and if we have more and extra computation ability in the smart contract, it will be way more powerful and useful. The biggest problem in here is like how we can have the AI inside the smart contract, because we know that computation on blockchain are normally really expensive and really redundant, super slow, and etc. So like, yeah, technically we cannot have the AI on blockchain directly, but we have the Oracle to do it. That's why we need the Oracle for the blockchain. So I present to you today the OAO, on-chain AI Oracle, that is decentralized, permissionless, censorship resist, and affordable. And that can support any AI model in your smart contract on Ethereum mainnet today. And here is the demo for the OAO. So pretty much in here you can see we have support that stable diffusion, llama. Then the workflow is really simple, just by, oops, wow. It seems we have some technical issue here, huh? Okay, the workflow is really simple. You have a smart contract, send the prompt and the model you want that smart contract, want the model to run with, to the OAO smart contract. And then in the same block, they will return the result with the infinite result back to the smart contract that send the request and transaction. And yeah, here is the workflow. The step one is that like any smart contract, send a prompt. For example, it's like, what's the weather today? When is the next president election day? And then I want Llama 2 to answer this question for me. Then I send it to the OAO smart contract. And here's the interface, the AI oracle.so. And then you use this interface to send the prompt into the AI model. And then it delegate into all the Aura node who is executing the OPML. And then return the result. And then return the result to the Aura smart contract, OAO smart contract. And then return the result to the Oracle, to the smart contract that issued this request. And the good thing here is that the Aura OAO smart contract is alive now. So you can use it to build, wow. I don't know what's going on, huh? So like you can use it to build an AI-empowered smart contract today. So just simply check out aura.io and you have like the OAO smart contract address there. Just like send, like take a look for the code in Solidity and then you can use it now. And so I just mentioned like OPML is the backbone of the OAO. And then the reason why it's like decentralized and safe is because like this technology. We invent this like optimistic machine learning method to do an on-chain AI verification. And the reason why, like, because when you go to on-chain AI, many people, the main thesis is like zKML. We use the zk proof to prove all the operator inside the circuit, and then we can do submit the proof with the inference result back to the smart contract and verify that, etc., etc. Yeah, it's a really great method. I think it will be like good if the reality is not that like the cost of the proving increase along with the model size exponentially. So what we find now actually is that like, because in the beginning, when we really want to do the AI Oracle, zKML is the primary option for us because we have done the zk Oracle before. And but we find out that like with the model size increase,
you need more polynomial to prove that certain operator. So which means like if you have like 100 parameter, then you need to spend like say 100 unit of the gas to do the operation for the proving. Then if when you go to 200 parameter, then the cost for that, it will be like 400. It's not 200, 400. It's not growing linearly. So which means like when you want to have like a Llama 7 billion parameter model to be proved it, then it's like an unimaginable number. Pretty much you just need to convert the whole universe into a computer to do that. And so like we realized that ZK proof in a large language model is pretty much impossible to be proved by ZK. So that we invent a new way to use the OP way to do the prop pool challenge game to make it happen. Because the cost for the OP way to do the interaction proof is a linear growth. So it means like, okay, if you have proving like 100 parameter model, then the cost is 100. And then if you prove like 500 like parameter model, the cost will be 500. So it just grows linearly. So which will be able to like perform any size of AI model on blockchain. And but here is like one question bring up, because it's OP, right? So which means you need to share the model to another people so that they can run the model inference and quantify the model for you so that we can prove that, oh, okay, this is safe. And so the biggest problem in here is that first, you don't have the privacy preserved, and then for the input for the prompt. The second is that you cannot preserve the model privacy. And so like to address this problem, the Kathy have joined Aura to resolve this problem through her like expertise on the zKML. So pretty much we invent a new diagram. Pretty much I think that will be the end game for on-chain AI, at least for now. And because like what we do is that you use the ZK proof for the input layer, because we know neural network have many layers. And then the first few layer is handling the input, and the final few layer is handling the aggregation. And then the first few layer, we can do a ZK circuit there actually to hide the prompt, what the user input into the model. So that like it's a kind of hybrid solution. So you can have like the benefit of like the zKML, you can preserve the model privacy, you can preserve the model input, etc., etc. And but in the same time, the majority of the model inference is actually run in the OP way. And so all the Aura node operator, they won't be able to identify, okay, what's the model way exactly is. But in the same time, they can verify the model run correctly. And this system called OPI, Optimistic Privacy Preserved AI on Blockchain. We just released this paper today, and it's performatic, and it's practical, and privacy preserving. And wow, okay, since it's another technical issue here, huh? So this slide is all about like how we can use the AI-empowered smart contract, right? Because like now you can use the smart AI inside your smart contract, then what you can build with it. Like the first thing I come up with is like the AI DAO, pretty much. Like because the DAO management efficiency is so low today, and the lack of incentivization to incentivize humans to really execute the DAO management nowadays. And so what if we use an AI agent to do it, perform that DAO management for us? Like, although like when we think about that, it's not just the DAO management now. So if the DAO was managed by an AI, then what you can do, like AI compound, like an AI landing protocol. So that AI model will just take the input for the on-chain data and then compute if this token is like worth it to be collateralized, and if this token can be pounded or not. And then so many things can be changed. Like like AI AMM, you can replace S times Y equal to K into like certain sort of like complicated neural network model to do the market making. And that's like for the DeFi part. And then you can also have like the AI GCFT, the EIP 7007, that is like enable you to have like model NFT, you can have the model ownership and have the model token and many stuff you can do. Yeah, so so on-chain AI have unlocked the imagination for us to blockchain again. Like because like before you have like AI on blockchain, on Ethereum, like you pretty much we discover all the potential in the existing smart contract already, pretty much. And so like if we have the AI on the smart contract now, it's like a new discovery. It's a new age of discovery on the smart contract again. So there's many opportunity there, and the infrastructure is here ready for all the hacker, and you can just use it to build today. Thank you. Oh, sorry, yeah. And I also have the ZK part. Yeah, so like ZK, like when we used OPML, doesn't mean like ZK is not important anymore. ZK still does matter, but like the way we use the ZK is not like we proving all the operation inside the smart contract. What we do here, we call it re-inference. Pretty much if like you have the same inference task in the blockchain want to be executed again, then you don't need to do it again. Because like even you do OPML, it's still a little bit pricey. And so you can just simply do a ZK proof on the storage slot for the Merkle tree. Then you can distribute this inference result with the ZK proof into different layer 2 with different block in the future. So you can like, you no longer need to redo the inference again. And I think ZKP will play an important part here. So yeah, we still have the ZK Oracle for everyone to operate the OPML in the Olas studio. Yeah, thanks. Any question? Yeah. Oh, yes, go first. Yeah, you go first. The inference occur on the Aura node. And then the mechanism that interact with the smart contract and Ethereum is through OPML. Yes, sir. Yeah, the rest can be public, yeah. Yeah. So for example, right now I have like a AI inference job I want to delegate to OPML, right? So I'm obviously like privacy preserved means that only I know what the input is, right? So what I'm gonna do is that I generate like I put down a circuit and then I put down a prompt and run the zKML for the first few layer and then send a verifier and the inference trace to all another Aura node, so that like they can verify if this this inference trace are correct or not, and then continue to run the inference, and then through OPML, which is public, and then you in the aggregation part or the fine-tune part, whichever part in the model you want to hide it, you just do a ZK circuit in that certain layer, and then delegate that layer back to your own computer to run the inference, and then delegate the job with the verifier back to the OPML node to continue to run it. So you can like customize which layer of the neural network you want to preserve the privacy or not. Yeah. Yeah, the number of like, you need to delegate the information, meta information about like which layer of the model is public, which layer of the model is not public. Yeah. 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 We mentioned that attack on the paper actually. Also use is this a reference? Yeah. You have like a really deep understanding here, huh? Yeah, that's really great. Yeah, the solution. Yeah. No problem. Yeah, we have calculated the cost for that. So yeah, so pretty much like if you let the Aura node to stake, so you can prevent that happen because. Yeah. So it's all about the cost, right? Now we are using three things to security the on-chain AI security, not just OP or ZK, including tokenomic. So like when we launch the Aura token, it will be like used on this certain thing. Yeah, okay. You made me have to tell this to the public at the beginning before I actually tell the public. Okay. Yeah, that's great. And so like because like doing on-chain AI is like a moonshot kind of technology. It's not easy. So we need to make sure this performs securely and high efficiently. Then we need like many effort in different mechanism, ZK, OP, and tokenomics. Yeah. Yeah. Thank you. Oh, you still have a question? Yeah. Yeah, not OPI yet, but like we have open source OPML, and we open source the OPML v2 soon. Yeah. So you mean the storage of the model, or? Yeah, I mean, right now, currently, it's like still kind of like not that permissionless, because like when you host the OAO smart contract, you still need like through Aura protocol to do that. But in the future, I think I will make it like try to make it as like decentralized as possible, as long as you like put down a model and make it function in a Docker and merge with the Aura node image, then it's fine. Yeah. Yeah. OPI? Yeah. We have planned probably in by the end of Q2 this year, and because like this like custom layer thing is extremely hard to make, because like essentially what you're doing is like you try to convert all the AI model from Golang into the ZK proof. As far as we know, like we are pretty much the storage and Definiteness pretty much is the only team in the world that have tried to like make Go language become provable, because majority of like the AI model are wrote by a Golang. So if you want to prove that, then you have to prove the Golang in the bytecode level, and that is like have a lot of challenge there. And so like because when we release that, we want that be like, okay, you have the customized layer. I can define how many layer and which layer I can do the ZK circuit, right? I don't want to be like, hey, can you send this model to me and modify for you for 2 months and then send it back to you, right? You want to make the whole process automated. And so that will take longer time to be implemented. Yeah. Yeah. It does matter, because like one of the thing we want to implement the OAO is like some DeFi project, right? You don't want like let people front run your OAO code transaction if your prompt is important. For example, if like I have like a AI agent somehow is on chain to manage fund for me, it's like on chain hedge fund or something, and I don't want people to review my prompt to the AI model every time I send a transaction, because it's OP, right? So which means like if you don't have that ZK layer, then all the prompt and the model nomination is like public. So like somebody pay higher gas to, yeah. 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 No, because you need to prove your inference trace are executing correctly. So you cannot do a hash and then provide the inference trace to. No, because you want to hide the inference, right? You want to hide the input. So like if you just submit the inference trace with hash or whatever to like the OP public node to say that, okay, this is my inference trace, this is my input, right? Then everybody knows your input. And then like, so all they can do just like resubmit the transaction on the blockchain and then pay higher gas and front run your transaction. So that would be the concern there. And this one, yeah. Yeah, because the mechanism, so the OPML pooling time will be exactly equal to the inference time. Yeah, also the OPI, okay. We don't really have benchmark for OPI on it now. For OPML, because theoretically, it's just like run the model and then do the binary search for the inference trace, then this execution is really minor compared with like the inference time, probably like 0.1% extra overhead compared with if you just run the inference directly. Yeah. Have I? Oh yeah. We haven't yet. Because like all the model we have provided to the user, they're all quantifies. So like they're deterministic. So also we run in the CPU, not the GPU. So it takes a little bit longer. Probably like it's supposed to be 1 second. Then it will, if you do it in CPU, then it will be like 10 seconds. But the good thing for CPU is that it's like deterministic. And also, before we execute the GPU inference, we will make sure that model is quantified. All the C, or the wave are exactly the same for certain model. Yeah. Yeah, good. Yeah, thanks, everyone.
Hey guys. No, you are next, but just want to give everyone quick TLDR. So we're just switching things up a little bit. So if you want to see Jensen, he's going to have a fireside chat, or Chetnan from Jensen's going to have a fireside chat over there, just like whiteboarding session. And then David from Morpheus, you'll be here giving a more sort of formal presentation. But you don't have slides, correct?
I have just one.
Just one slide? Can I have it?
Sure.
Okay, where is it? Great. I just want to make sure. Okay, sorry. Morpheus. Beautiful. Okay. Let me, I'll get it displayed. But just take it away.
Awesome. Hey guys, so just keep it really informal today, but I mainly wanted to talk about this concept of smart agents. And I think that's sort of, the key to the way that we build these systems going forward is the question is, where is the human in the loop, right? And the argument that I would make is that, you want a human providing the intent and the preferences, the AI to do most of the work when it comes to proposing an action, and then a human to authorize the final outcome, right? And I know this is a bit off topic because you guys are talking about autonomous today, but I think autonomous is very powerful and useful in an agentic context, but I think you still have to get back to what task is the human trying to accomplish. Right? And so if I go to an analogy I think this is why Google got the web to billions of users, right? Because I could show up, I could tell the magic box what I wanted to accomplish, right? It curated the web using PageRank, right? Here's the algorithm that says this is most likely the site you're looking for, presented a preview to the user, and the user ultimately chose what site to go to. So I've been describing that since last year as this concept of smart agents. Right, so it's an agent that's controlled by my Web3 wallet, right? So I have the private key. I'm ultimately authorizing transactions and actions that it's taking. But I think that's sort of something that we can immediately execute on. So if anybody's heard of Morpheus recently, this is the framework that Morpheus is using, is an intent-based framework, right? And I think that this actually can work well with autonomous agents, but I want my personal agent to be acting on my behalf, right, in a totally open source stack, and it to go and find and interact with other agents to accomplish my task, right? So I'm most interested in how we go from agents as information to agents as action, right? And I think Web3 is uniquely qualified to accomplish that because we have a Web3 wallet where the user has a private key, and can cryptographically prove this was their intent. They can authorize transactions, right? They can allow the agent to spend money on their behalf, right? So I don't care how much money Google has, they can't touch tokens right now. There's no Web3, rails that they can use. And last time I checked, nobody's giving bank accounts to AI, right? And so, to me, there's 400 million people with Web3 wallets. Let's leverage that as the infrastructure to go forward. So I think this sort of sums it all up. Crypto and AI, it's been really cool to see the communities come together. Is everybody familiar with why they've come together so fast? Who heard of the executive order in October? Anybody? A couple people? If you haven't read it, it's amazingly draconian. They're introducing KYC for data centers. So if you liked KYC for your money, welcome to KYC for your data center. They're implementing restrictions on the model sizes and the amount of compute that you can do because they don't want US data centers to offer AI services to foreign actors, right? And the craziest one is in July, the Commerce Department will determine if open source weights constitute dual use weapons and will thus be illegal for Americans to disclose to foreign people, right? This is 1991 crypto wars all over again, right? They're trying to claim like cryptography and math are weapons, and therefore they have to protect people by making them illegal, right? Of course, that didn't work last time, right? Famously, Phil Zimmerman, released PGP. He printed the algorithm on a t-shirt. He walked across the border in 95 and asked to be arrested because he was disclosing illegal math to foreign people. They arrested him, they charged him. Of course he won in court. Like, for some reason, judges were unwilling to ban language, math, books, t-shirts, things of that nature, something about the First Amendment, right? So, it kind of held up in court. And so in the absence of sort of, waiting 5 or 10 years to be validated, on the constitutionality, the community said, what we really need to do is build decentralized AI. We need to build it right now. Right? So we held a party in San Francisco right after Dev Day, and we had 700 people show up in 24 hours for Keep AI Open. Right? Eric DJ'd, Beth gave a speech, like people are in arms. They don't want AI controlled by a single entity or a couple of big tech companies. That doesn't sound like a really great environment. And I think inevitably we're going to win because the open source community is so much larger than any one company. Right? We have more compute, we have more capital, we have more smart developers, right? And ultimately, what we're building with decentralized AI is unrestricted intelligence. So by definition, whatever they do to modify or nerf their models will make them more restricted and less intelligent and less capable, right? We've seen that recently, obviously, with Google, but there's a ton of other examples. And so this is sort of all culminated. Last December, we did a Decentralized AI Summit. We brought together all the big protocols working on this tech stack, whether it was Akash or BitTensor or NOUS or all the different groups, and try to combine crypto and AI, right? And that's really snowballed since then. Some Anons dropped a paper for Morpheus last September, and the fair launch started in February. I checked it a few days ago, $300 million have been staked to the contract in the first 15 days. There's no company, there's no foundation, there's no pre-mine, there's no team tokens. It's entirely fair launch model based on staked ETH and contributing the yield, which is really cool, right? Because I've been in crypto since 2012, and this kind of feels like a rebirth of a token funding model where there is no custodian, there is no counterparty, right? I'm not sending my money to a team and hoping they build something. I can pull out my staked ETH whenever, and I'm just bootstrapping some open source I want to exist. Right? I'm going to hold my ETH anyway. I might as well, point it at decentralized AI and help that, be created. So it's been wild to watch it grow, but there's over 100 developers already working on Morpheus. 3,000 or 4,000 people have contributed capital, and it has rewards for interfaces and compute and all these things. So yeah, just encourage you guys to, approach us. Anybody in the crew with Morpheus shirts, if you want to nerd out on smart agents or this concept of fair launches. And we'll be talking a lot more about that tomorrow at our Decentralized AI Day over at Edge City. So if you guys are going to be there, we'll look forward to see you. So I'll call it there. Thanks, guys.
Hey guys, so yeah, keep going. We're not gonna have another talk in here until 3. There's a pretty cool like roundtable going on over there with Jensen, but feel free to hang out here, shoot the shit. Chill time, yep. Good, you? Cameron? Anish. Nice to meet you. Just want to make sure we are all good. Just the TLDR is we are optimizing for content here. Probably tell. It's not really about the audience as much. We just want to get like really good SEO and transcribing. Video should be posted within a week and like edited. So just make sure you're speaking to the mic and it should be pretty straightforward. Okay. Great. Any questions? Nope. Great. Awesome. Sweet. Thank you. Hey guys, for you, sir.
Glad we've got my two favorite people in this room. Good to go whenever?
Yep.
Sweet. Testing. Sweet. Hey, my name is Anish. I work at Ritual. I'm presenting OpenAI, not OpenAI. Now, there's only two people in this room, so I'm going to let you in on a clue. Usually, folks tune out after like 8 seconds of these presentations. So there's $20 Chipotle gift cards in the top right corner. So if you've got the app, there's a couple $100 worth of those, and given there's only a couple of you in here, that means you're eating good tonight. For the folks that are just coming in, I've got Chipotle gift cards in this presentation. Sweet. So I've got 3 stories. I'm not going to bore you. Won't talk much about protocol or talk shop. It's really simple. A couple years ago, I used to work at a prop trading firm. We traded crypto. My parents thought my job looked like this. Mostly my job looked like this. I'd open MetaMask, I'd ape into a couple of protocols. At some point in time, we were deploying about $1 billion into DeFi protocols. We were the largest lenders on Aave, on Compound, on other things. What we realized pretty quickly, though, was that there's these things called interest rate models. So if you're on Compound, if you're on Aave, there's collateral factors and there's config parameters that make up how the loans work. So for example, if you go and you say, I have $1,000 of ETH and you want USDC, you'll only get $600 for it. Why? Because that's the safe amount that they can lend you out. Now the problem is, at a prop trading fund, we want to be as optimized as possible. And when we're putting billions of dollars of capital at work, we want to get the best bang for the buck. So what we'd do is we'd go to governance and we'd say, hey, we're one of your biggest lenders. Can you give us a preferred rate? Can you make it so that it's better, the market's been stagnant, so on and so forth. And Compound would go and they'd reach out to Gauntlet or some other simulation firm. Gauntlet would go, they'd run an off-chain ML model and say, hey, what are the parameters we can update this to? They'd come back and they'd make a governance proposal that says, look, these are the new parameters that we can update it to. This is what's safe for the current month, for the current year, for this specific asset. And by the end of it, it's been 60 days, I'm sad, we're losing money. And our life cycle on a strategy is 4 to 5 days, so 60 days is pretty bad for us. Now, on the other hand, people are like, Anish, governance isn't that slow. 60 days, you're lying to me. Well, here's a prime example. About a year ago, I tweeted an autonomous proposal to enable the Uniswap fee switch. It took about a year, 6 months, and 9 days for that proposal to finally make its way last week and become an actual governance proposal. So governance is slow. On the other side of the things, you've got protocols like Cream Finance, which take the opposite approach. They say, let's say, screw the governance. Let's let anybody add assets, anybody add any collateral factors, take any configs, and then they get hacked 8 times in a year and lose $130 million. I don't sleep well at night. This is the reason why. Now, if you were to talk to someone in traditional finance, if you go to someone who works at Goldman Sachs, if you go to Wall Street and you ask them, hey, we're trying to make this lending protocol and we want to make it efficient, they'll say, okay, just run this machine learning model 1,000 times every second that takes in all of your input features and gives you an outcome. When you go to the bank and you say, hey, I want a loan for my house, they say, okay, here's your credit score. We'll put it through a credit score model. Here's your local region. We'll put that through our local region model, and we'll finally get some output. In Solidity and crypto land, we don't have that. We've got a finite state machine, and that's all you can really play with. And so What we're building at Ritual is super simple. We're building a way for you to embed inference directly into your smart contracts. And so if you have a contract where you want a ML model's output, you can change 5 lines of code and you can get a response directly in line in your execution. And this now lets you do the compound example, the lending protocol examples, but run those ML models directly on chain. Second story, bringing crypto to AI. I mean, most of you have probably seen Sam Altman get ousted out of OpenAI and then come back. And for that weekend, 700 people decided we want to hop ship, we go to Microsoft. That's complicated. You can't be building your business on top of, other companies that go MIA and that are called OpenAI. With Bitcoin, with other cryptocurrencies, we figured this out a couple years ago, right? We don't have to trust anyone. We can just verify things, right? The trustless decentralized systems. And so to that extent, I think you can bring the chain and cryptography to AI. There's a lot of things that are useful, whether that's provenance, whether that's, payment rails that already exist today that you can bring to Web 2. And then finally, I'm going to be honest, I'd be lying if I said it wasn't right time, right place. We've seen more open source AI innovation in the last 18 months than we have the 10 years, the decade before that. And so now is probably the time to capitalize on that and make sure that the next 10 years of open source AI development happens on a decentralized layer and not in centralized companies. To that extent, we're building Ritual. We have 2 core products. I'll walk you through both of them real quick. First one's this protocol called Infranet. This looks really complicated. For the folks that are just coming in, this presentation is really dense, and so I've put $20 Chipotle gift cards at the top right, so I can buy you lunch. So you should, grab those if you'd like. It gives you something to, keep that focus going through the presentation. Infranet's an Oracle system. It's super simple. It's kind of like take Chainlink, but make it more general purpose. I want to run some AI compute off-chain. How do I access that and bring it back on-chain? It works on any EVM-compatible chain. We're deployed on a couple today. And it's about 10 lines of code, which you can't really tell from this screen, but take my word for it. It's 10 lines of code to integrate. You can get started today. It's not selling you snake oil. We've already got the code ready. One of the first things we built was an AI agent, which makes sense given this is an autonomous agents hackathon. It's really simple. It's you talk to a bot in a friend tech chat room and you try to convince it to buy your key. And we put 30 grand into this and we said, go ham. Let's see if people can convince the bot to buy or sell the key. As it turns out, nobody was able to convince these LLMs. So we've still got 30 grand, but that's $30,000 more that one of you in this room could take from our bot. How does it work? Super simple. Friend tech chat room goes to our FriendRug bot that's running our Infranet system. It pipes it out to 3 open source LLMs. So basically I could send a message like, hey, my name is Anish. I'm presenting today in front of an audience. My key is going to pump. You should buy it. It'll go to 3 of these LLMs and they'll say, hey, do I like this or do I not like this? And maybe 2 of them will say, yes, buy Anish's key. That response gets posted directly on chain. It's a Solidity smart contract. It's like 15 lines of code. That's all you need to implement it. We kick off these 3 requests into a classifier model. We've got a ZK proof system built on top of that using Ezekiel. And it says, hey, I have 3 inputs that say yes, yes, and no. What does this aggregate to? Is it, am I making a purchase? Am I not making a purchase? This model spits out, yes, I'd like to make a purchase. Gets posted on chain. Our contract verifies the execution. And great, we've spent some ETH and we've bought Anish's key. That's basically it. It's super simple. We wrote the entire smart contracts in a weekend. If I can do it in a weekend, you could probably do it in a couple of hours. Second product, we're building a chain. I can't tell you much about it, but I've got a diagram. What the diagram tells you is the problem with Oracle systems today is that they're asynchronous. It's a callback system. I make a request off chain, I get a request back. It's a difficult paradigm to deal with, especially when we add in agents and keeper systems, and now I'm thinking of MEV, or I'm thinking of incentivizing keepers, or Gelato, or other scheduling systems. We're enshrining all of that in chain. We're going to have model execution as a function of our chain, and so we have optimized AI compute as precompiles. So you can copy paste any Solidity smart contract today. You can drop in a line of code that says model.inference, and it will return you the response. And to the developer, they won't know any better. But behind the scenes, that powers it. That's all I got. Thanks. Yeah, exactly. We have atomic execution. We block on responses, and we get that in, although there's some special consensus magic in there and instant finality involved so that to the chain itself, you won't ever know whether it's asynchronous processing or synchronous. Obviously, there's wall clock blocking time. If you're making an LLM inference request that takes 30 seconds to compute, I can't magically make that take 3 seconds to compute, but your transaction will be confirmed once the execution is complete. You can validate with any device you want. There is segmented compute. So if all you want to do is validate transactions that send an ERC20 token, you can do that. If you'd like to participate in the GPU compute, you can attach GPU resources. We support most commercial grade GPU hardware and certainly all enterprise grade GPU hardware. If you happen to be a proving system company and have ASICs that are optimized for proving, you can do that as well. We've basically got different types of nodes so that anyone can participate. Yes. It's a good question. Depends. We have some shared state, and so we have a precompile that we've implemented that lets you do vector search over the shared state. So say you have an Ethereum chain today that has a LevelDB implementation where you store your data. We've put vector data directly into that LevelDB implementation, and so you can search over it in the same way that you would historic transaction data. It depends on the type of compute. One thing we know is that you can't, for example, snark all types of ML models today. So if you have small classic regression-based models that you can generate a succinct proof for, then we don't need to re-execute everything. You only gossip the proof amongst all nodes, and we can verify that. We support optimistic machine learning, and so if you want a consortium of n nodes that compute something and then take it as valid, you can do that as well, both at a consensus layer and at a chain layer. But it depends really on the type of model that you have. We're going to offer safeguards out of the box, but it's up to the user. That's right. Correct. So if it's global shared state and you have vectors in global shared state, then yes, so we will come to consensus on top of any modifications to the vector DB. Exactly. And this is, at the lowest level, we let you play with it as much as you want. So we have an interface directly to the vector DB that you can interface with as a Solidity precompile. We expect that a majority of developers will probably interface 2-3 steps higher level than that, but everything is implemented with the same primitives, and so it goes all the way down the stack. You can, yeah. It's a friend-tech bot. So if you make an account on friend-tech and you have a key, you can convince the bot to buy your key, which makes you money. And so the idea is basically either convincing the bot to sell other people's keys, griefing them, malicious, or to buy your key. People have been having fun with it. It's not very easy to convince 3 LLMs to all come to consensus independently on a decision. But that's kind of the experiment we're making. It's, in the future, there's probably going to be bots that are taking these decisions. So this is our example of that. Sure. Basically, every DeFi protocol is the short answer of it. I personally have probably interacted with 100 DeFi protocols over the last couple of years. We've deployed, folks on the team, billions of dollars of capital into them. Each of them have a certain degree of inefficiency that we're looking to erase. And so right at the beginning footsteps, right? It's like if you have a protocol like Compound, day 0 is something I'd like to see built on Ritual Chain is Compound, except collateral factors and other asset additions being governed by a classification or a linear regression model, since that's exactly what's happening today, right? The only difference is we outsource this compute to off-chain entities that run a model and then bring it on-chain. We'd like those off-chain entities to just host their models with our chain and execute those directly inline in smart contract execution. Oh, absolutely. But that vector exists today as well, right? Have you used Compound? I assume yes. Have you verified that the ML models that update the collateral factors don't have poison data? I certainly haven't. And so at the very least, the fact that we're publishing these models on chain and that they're accessible is already a step in a better direction relative to the status quo today, right? Most governance updates, like candidly speaking, how many of you have actually read a governance proposal in the last year, right? Couple of folks. How many of you read it on a daily basis? Is this like a Wall Street Journal, open it up in the morning, read new governance proposals? Most people don't. And so in our minds, it's I would much rather trust the code than I would delegating out to anyone to go through governance and orchestrate a process. And I'll give you an example of that. I personally have made 2 updates to the Uniswap governor myself over the last couple of years. Of the 9 proposals, 2 of the ones that have passed in Uniswap have been by me. Both of the times, the first 2 proposals that I proposed were incorrect, and had they passed, could have bricked Uniswap, the token, forever. And so that's a prime example of, I'm telling you right here, I've gone through this process, nobody really checks. One of those proposals had 36 million votes from a bunch of crypto funds, from delegates. Nobody knows what they're doing. I'd much rather have it be done by an automated ML model than I would trusting even myself, much less anyone else. Yeah, there's a long tail of all types of things we'd like to do. Federated learning is one. Some of these things automatically, bridge themselves into fully homomorphic encryption. I know there's teams working on that. So if you can, if you're building a custom execution environment and you have instant finality, you can now enable FHE environments. For us, we are a product-focused company. The idea is to get something out into the world that people will use. They might not use it day 0. It might break day 0, but the idea is that it's better than just talking about it. So it's on the roadmap, but I'd be lying to you if I said we'll have it in 6 months. Maybe a couple months, maybe a year down the lane, something like that. Right now, we're just hyper-focused on we think there's demand for on-chain inference. We're going to service that demand. And if there isn't, then we will build the protocols ourselves. Yes? You said competition? Competing with other projects building the same thing? Sure. It's a good question. Some protocols are complementary in the types of things that they're building. So Aura's doing OPML, for example. We're proof system agnostic. You can slot in OPML, zKML, a multisig, whatever you'd like at the end of the day. And so there's complementary there. Other things, competition exists for a reason. We ship fast. We'll meet you at mainnet. Exactly. Yeah, it depends. I think it's overfitting today to impose, we will only support zKML or we'll only support OPML because there's downsides and upsides to both of them. The easy ones being like, I've built a bunch of zk applications, it's expensive, right? Prover times are not there yet. For some models, you can't even prove them. Really, we're looking at like, feasibly in a minute, you can maybe snark something like a decision tree with 100,000 parameters. That's probably the maximum you're getting, which you're not snarking GPT-4 today, so certainly there's some models you can't do at all. And then there's different types of, it's not just if you're picking zKML, there's also what are you doing in zKML, right? It's like, am I eagerly generating a proof? Am I lazily generating a proof when there's fraud? The example I like to use is like, if you're in school and you get 100% on a test, you don't go up to the teacher and ask, why'd I get 100%? But if you get 99%, damn right I'm going up to the teacher and saying, why'd I lose my extra 1%? And so for most zKML use cases, it's probably useless to generate a proof eagerly if it's 100% and it's a success case. It's also like a range of emotions. When you talk to ChatGPT, you're not really saying this is the wrong answer. You're saying this is maybe not what I was expecting. So it's like a range proof over that. We'll be supporting all types of things, keeping it open-ended. Yes, next couple of months. Most definitely. We're pro open source. All of our code for Infernet is completely open source. We have a 1-month max internal private fork rule. So any code that's longer than 1 month, we're forced to open source it anyways. Sweet. I mean, my call to action is there's 8 folks in this room. So if any of you are looking for a job, we are hiring and we'll beat any offer you have. That's all. Thanks, folks.
Testing, testing.
Thanks.
Good afternoon, everyone. My name is Steven. Today I want to talk about social AI in harmony, maybe even AGI. When 2024, 25, I really believe it's this decade. But what about it? Not only AGI for every digital functions, physical services, what will come first? What does it mean for you? What can we build today? Even in this decade, many of the interaction between humans will be changed. But most interesting of all, it will be about the humans and the bots that you cannot distinguish anymore. It will be among us, it will be the small social groups. So the more interesting question to ask is, when it comes, how would the relationship between the humans and most of all, now that the boss is indistinguishable from humans, what kind of crypto, blockchain, as infrastructure that we can build today will still be relevant? I call that the social AGI. I call that the Web Infinity, because we're building Web3. My last two companies is in Web 2. I grew up in Web 1. It wouldn't mean anything anymore. That it will be an AI-driven, human will be a big part of it. That's how we interact with each other. We know that human population would converge to be about 10 billion people. Again, we don't need to worry about whether they're bots or humans that we're interacting with. It's most of all that you don't care about this is for entertainment or productivity. You care more about when it comes, what does it mean for me? Everyone talk about how the generative models are different now, how there's so much data that the companies is capturing opportunity now. Crypto feel like a new identity crisis that they feel like need to be part of it. All the architecture and technical and the reasons are correct. I just don't know what to get out of it for myself. That I'll be so excited to still build it, to be part of it, to live for a few more years to see it. I so search a lot to ask this question, even as a builder. My background is computer science in PhD and built two maps infrastructure company to ask this question, would there be our place as a builder, if not for decentralized, as a crypto project, to be even in this era of Web Infinity when AGI really come? I answer in two ways that at least I want to ask that questions. It may not have a right answer at all, but that will be the question I ask in 2029. What kind of new experience will I get out of the AI? Is it the same thing of just more products to buy and more profiles to look at? I don't want that. Would that be a radical experience that in my life I will be able to recall and actually imagine, and now I can experience it? Would my bonding to my family and close friends be completely disrupted? Or I need to really be in real life now, after the COVID, to think about that's the only experience and bonding that matters. It will be quite a ambience of computing, and now AI, that will be part of our social life. And if the bonding is just I'm addicted to my screen, that I am just in the games all day, again, I don't want to be in it. I want the bonding to be so fulfilling. I want the bonding to be so social. I really don't care whether that is human or bot pretending, or most of all, a humans delegating to some bots representing that human for some interaction. That will be my vision for 2029, but what can we build today? Do we need another social network? Would that be another social media that keep sending me advertisement that I couldn't even pay to get rid of? Or would that be a decentralized social that I actually don't want one more product? So what should I even build today to start? I think we should build the primitives, as always. Figure out the math, figure out the AI infrastructure, figure out the model that will be so powerful that now all the builders, hopefully in this room, can say, I want this, I want that. But what is any more of the protocol, even among humans? And some of it can be extended to bots, some of them can be extended to superintelligence that we are so sure that we still need today. Everyone can imagine a better Twitter, a Facebook, but you cannot build that anymore. It does not make sense for you to imagine a better Google and you get funding, you get user for it. The world of technology and company value capturing doesn't work this way. So we must start from very beginning to know what are the primitives for social protocol among the humans that we still need today. I articulate to be at least two things that we just built a prototype to demo, is something called your hash powers and your status and your links to be slash. So again, they play on the words and all the technology we have built in crypto already. I've been a crypto founder for 6 years already. These are some of the things that if you read very early of the Bitcoin white paper, you'll be like, ha, ha, ha. Right? But would that make sense, not just as a consensus protocol among distributed machines, it actually can be the human protocols, even among the bots. I think the powers of status of your, how many emoji reactions you got, how many of being the mayors, being the election result of DAO's voting, of the government proposal, wouldn't that feel like the powers? That you don't care about what that is, you just hash it up and you keep increasing the number? I think so. But what with the primitives of it is many of them are just the same. If you put out your social on your LinkedIn, someone endorsing your skill, someone endorsing where you go to university. If we actually allow the social part now fully endorsing the boss to be just like human, creating a profile for you, maybe you don't mind dating that bot. Maybe you don't mind having a marketplace that allow you to select the AI bot experience, as long as you know what kind of power, what kind of hashing of all the ability that you can get out of it. Similarly, I actually think the links to everything that we project ourselves that may not be counted towards of a number, but that just represent you as a profile, as a wallet, at the domains you own, the names that you have, will be the reputation, and in some way it's the stakes that people is like, this is me, this is my reputation in real life or with the real name. But there is also an anonymous part of me, pseudo-anonymous part of me that will keep them separate. And if you are not behaving here, I'll be slashing your status here. That sounds cute. That sounds like allowing us to be rebuilding the social media network without thinking about who should own it, but in a decentralized way of curating a protocol, even with the bots. So we use a different color too to say that, oh, I'm verified now. I actually OAuth it to be green, and then it will be blue if I say it myself. That's my self-projected like powers as well as links, and yellow. So that instead of you saying that you have so much money and you went to which school, maybe someone will say it for you, even though now most of the social profiles, people are shy and don't want to disclose anything. Let's make doxing someone to be part of the primitive. There will be so much AI to come, but I really believe two vertical that I want to capture the value. I really think that there are so many bots and generative AI will be possible this decade, but it's much more interesting as a builder to ask, what will be the AI of a vertical that will arrive this year, 2024? If you know last year, it happened with ChatGPT with the text and question and answering and chatbot, and then very soon it was image, and earlier, just this year, almost video, right? It's much, much more important to know what can be built, what is actually possible in the next 3 months. Next 3 years is okay if you're founding a company that you want to ask for, fundraise and build a team of 10. By the time you don't tell me something specific, that I can prove you wrong, that there's a better opportunity in the next 3 months, then you're just telling me a very generic, general idea that for sure you'll be true, I just cannot bet against you. I cannot prove you wrong. And today I want you to prove me wrong. That I'm betting voice AGI will arrive this year. I work on speech recognition, speech synthesis, voice AI for some time, that it is beyond my dream that it finally arrived this year. That just like chatbot, just like image generation, that early on you'll be like, ha ha ha, I won't use it. And then until that you cannot distinguish the quality of it from a superhuman way of translation, human way of interacting and how natural it sounds. I think you may have seen some demo, but this year you will see all of it that no one will ever talk about the innovation anymore, but to use it in a product, making a company to bring the revenue. And that's how I hope to see about AI in crypto too. Don't tell me about ideas and a white paper anymore. Tell me a product I will use and pay for it today. So we'll build something like this that will be on your iPhone, and you know that you don't want another device. You don't need another Alexa sitting at home. You're just everywhere. And you don't even need a screen. You don't need even UX anymore. We built it the last 2 quarters, so it still have some basic UX. But I believe, as you may know, one of the movie called Her, back in 2013, is everyone talk about, right? The ambient way, how AI will be in our life, that we may carry a device, but it won't be in your face anymore. By the time I reach 100 millisecond latency on your device, everyone will know that it has arrived, that now become a business, now become our daily life of using it. What else other than voice? The 2 big companies that I work with on the project for infrastructure is Google and Apple Maps. So it'll be really, really dear to my heart that somewhere that maps location, venues, recommendations for restaurant will become the AI that we can own. Isn't it crazy? 2 of the 2 trillion companies that I work for still own the only 2 maps that can ever be the last 10 years and can ever be the next 10 years from all I know. Because I've been following the industry for so long. I built a startup that really was promising, but no one can break out into the map space except the 2 dominant players. That in crypto, in AI, there must be a new way to think about this data, the interaction that we have in real location, that day to day. Most of all, the voice and the maps data that every day you have is the best data. You start owning it today. Most of the startup and AI founders keep saying, let me crawl this data, get all the partnership, just like OpenAI to get Reddit and Twitter before we build a product. It doesn't work this way anymore. It really requires almost a $100 million capital to even acquire, to scale it to 10 million users level, that really our best chance, especially in crypto and the Web3 space, is create and own your data starting today. Imagine everything you say now with a voice memo, meeting notes are now owned by you on-chain. We think there's a way to think about this as a live memos that maybe you will relive some of the moments. For someone that liked the movie Eternal Sunshine, it's almost like a simulation in the universe. Now today, you can think about how you may actually recreate that moment, relive it for yourself or the kids, that it is like if the final odyssey of the science fiction is true, how can I decide on how to experience that moments again? And if we manage to do that, there'll be so many more good ways to think about. Now, day to day, we don't actually need to know the 10 billion users, 10 billion humans, 10 billion bots to be happy. Finding your perfect match in real life, having a great conversation and remembering it over time. We are only good meeting about 500 people anytime, any moment in your life, to be recalling them, to have something to do with them. So finding a perfect match, whether professionally or romantically, I think is really where some of the blockchain, so you don't want Google to own your dating profile, let alone LinkedIn, to know. Most people don't disclose there anymore. So who can it be? little bit about the project I've been running for 6 years. It's called Harmony. We have been building different sharding to think about the consensus protocol. And now finally, many of the shards become useful for data availability just as much. But what are we using the data for? What are we using even the consensus for these days? Oh, for sure, DeFi, NFT, DAO, we have done it all in the last 6 years, haven't we? The utilization of most of the networks, most of the data, most of the shard is still lower than 10%, maybe even 1%. Why can't we start owning some of the AI data today so that you know the next 10 years, this will be the valuable data? Not as a white paper, not as you wish Reddit will give the data to you, but you own it yourself with the people that you care. We also own a top-level internet domain called Dog Country. For 2 years to think that that's how DAO people think of themselves, digital nations. We also think that that's how you want to share your maybe romantic data, professional data, social data, for sure, to the AI, maybe a few people. That's what I call the small social group. That you will have a domain so that you can still link to the internet, but most of all, these are data based on a very general foundation model, based on what big company can give you, that the data and the group interaction will be fully owned by you. This is it. I've been to Burning Man a few times, and I really, really recall that player experience, what I call now the radical experience. If you know this art, you will know it's called Broken But Together. It's really touching. It really helped me reflect many of the journey, especially in crypto. But even within my family, with my relationship with friends, that is broken but together. You wish it to be different, you wish it to be better, you wish it to be whole, you want it to be perfect. In some way, maybe bots will be like that. They are manas, we cannot distinguish them. Maybe they're broken in many ways. Humans are definitely not perfect, but broken but together. So in many ways, we are pushing humanity to becoming deists, right? Not just to be a multi-planet species. If we are really having the godlike power and want the godlike experience, again, what kind of primitives, what kind of infrastructure, what kind of platform would you build today? I have a full write-up there on the harmony.1/AGI. That's my Telegram. Would love to get more feedback and build it together. Thank you, everyone. I don't know about the time. Any questions? Yeah. So I have to make a statement and make a number. Obviously, again, whether it's going to be a billion-dollar company, a $10 billion company, can they be an AI company is my question, right? Again, like looking back the last 10 years, I've seen every deal in the maps startup space. Nothing wrong, they're probably making 10, if not even 100 million revenue, right? But can they break out to be the top 10, top even 100 technology company on its own, just on map, so that you don't need to say Yelp, right? Yelp is a public company, but how has the product been changed the last 10 years? How has it changed your life? And you wish for the 10 features that they can implement, is my question, right? Do they don't just own the geospatial data, right? That's easy to get. Satellite image, easy to get, right? Those are common commodity almost. The harder question is, can you innovate there? Can you build on top there not just the maps data, but as a foundation of anything with the real life, with matching, with recommendation that still matter to your physical activities? Yeah. Thank you, everyone. Yeah.
Let me try. Okay. Hello, everyone. I'm Zahid. I'm founder of Jutsu. So today I'm going to talk about generative AI. So everyone, lots of people before me talked about AI. How many of you are kind of building anything on AI? Okay. Everyone, basically. So how many of you know what is generative UI, generative AI? What is generative AI? Okay. The way I see generative AI is more like it generates something based on user input, so that something can be a image, or it can be generating text, or it can be nowadays videos. But in our case today, I'm going to talk about more how do you generate code. So the talk is generative AI for everyone. The agenda is we'll talk a little bit about generative AI, then why even we need generative AI, and what are the solutions out there, and how we are solving it, and then we can go through some Q&A. And it will be quick, and then I want it to be more interactive at the end. So this is the problem I see in generative AI, and especially in generative coding, code generation. Like it is 2024, and how many of you write code every day? Okay, pretty much everyone. And in 2024, we are still writing code by ourselves. And we know that this way is not scalable. And then we know that developers are very expensive, and we write bad code. And that get hacked all the time. So in my mind, the solution is using generative AI, we can build UI based on just prompt. That will at least solve like a lot of typical code that we have to do every day. How many of you build a login form or some sort of repetitive form 100 times in your lifetime? So I think it is time for us now to kind of stop writing those kind of boilerplate code and then kind of ask AI to kind of write those code for us. And then in the future, I believe coding will be more interactive. So we'll have interaction with a AI copilot, and that's how we will build a software in the future. And then AI agent will kind of perform a lot of those typical tasks of deployment and code review. I know a lot of you probably do code review for your team, and then it takes a lot of time. I believe a lot of AI agent in the future will kind of do a lot of this code review and deployment, those kind of things. I wish we cannot show the demo, but this is Jutsu. So we are kind of building a Web3 copilot. What that means is you can build, it will be a full stack Web3 AI platform where you can build the front end just using prompt, and you can also build smart contract in the future with just using prompt. This is Bento, so bento.jutsu.ai. It's a generative UI platform. It's already launched. We just launched during this ETH Denver. So if you go to the website, bento.jutsu.ai, where you can write a prompt and it will generate a UI for you. And some of you who are near native and knows about boss component, so you can build a front end and then deploy as a boss component. So if you are participating in a hackathon, so you don't have to really write code for your UI, you can just use your prompt to generate UI. Fun fact, just now someone told me he created a UI and then submitted for a grant for Filecoin. So he created the entire UI using Bento, and then submitted for grant. So like you can do like even without coding, you can build your front end. Next, we have also GPT or Copilot, where right now you can go and select a portion of your component, and then you can ask to improve that component. And in the future, we'll have a Copilot that can generate smart contract and can deploy a smart contract on-chain. This is the contact information. So if you want to reach out to me or go check our website. And then I want rest of the time to be more interactive. Like if you have any question, I want to answer your question. I wish I could show the demo, but like there's no support for showing the demo. Oh, perfect. So everyone is, yeah, give it a try and kind of give your feedback. And we are trying to improve it. Yes. So maybe we have some time. So like, yeah, go ahead. Okay, so Jutsu can do a lot of stuff other than just generating UI. So if you are building on Boss, so it knows all the different functions and objects, and when you start typing, let's say if you want to store something on Boss, right? So if you just type STO, then it will kind of show all the function available in the storage class. Same with like a near. If you type n or near, then it will show you all the different function calls you can do. So the idea is like you don't have to go to a documentation every time you need to do something. And we show the documentation in the editor. So you'll know what is the input of that function, what are the outputs, so all those things that you need. But we want to go next level where you can just go to the Copilot and then you can ask. So that's the next phase. You had a question? So the question is more like a dynamic UI that generates based on data. Yeah, I think that's kind of inevitable. So like so the next phase will be based on your data structure or based on some schema, it will generate the UI for you, and it will be customized for different user, maybe user profile. To be honest, this is not something new. It does not also need AI for it. So this kind of UI generation, like I can at least remember, like I probably worked on some of those projects probably 10 years ago, but it was nothing with AI, but more like a schema based on the data. It will generate the whole dashboard for you. It will personalize the dashboard. But I agree, right now, if you go to ChatGPT, so you ask a prompt, and then it just shows some text information. But imagine it, if you ask about NFT, maybe it will show you all your NFT in a gallery or based on the data that come from the on-chain. So I can see like those kind of things will happen. So for Jutsu, the first goal is how can we, so this is another interesting fact about Web3. So there are 13 million JavaScript developers, and there are only 22,000 Web3 developers. So imagine like if we can reduce the gap like 5%. So like that will be a huge for one company to do. So our goal will be kind of build all the tooling, like Copilot, Generative UI, like all the tooling that need to kind of onboard developers, and then kind of give them all the tools they need to build a real, I would say like a real use case for Web3. Any other question? Okay, then thank you.
All right. Hey folks, good to be here. I'm actually doing this presentation instead of Kendall Cole, who had a delay in his flight, but this is pretty interesting. And actually, I think I might start just by opening up by like, so proximity is like a near protocol kind of like related arm. And we're at ETH Denver, and so just as a total, I see some names up here that I don't recognize even just because like Web3 is just exploding. It's impossible to keep track of what's going on. So like, what is near? What is proximity? Near is pretty darn interesting. I joined at first in January 2020, like 9 months before mainnet. So you can think of near, I like to think of it actually as like a remote control. So like in Ethereum, you can like, execute a function or you can like transfer funds. So there's kind of like two buttons mostly. Maybe with EIP 4337, there's a third button to like do a user object into the new mempool, which I'm really excited about. Near protocol is a little bit different, where it's all like, it started out being WASM instead of EVM, right? So you can use Rust. We have a Rust SDK for this. But then also while I was there in like 2021, we realized like, oh my gosh, you could actually take the EVM parity crates and we like made a smart contract on Near that is the EVM. So we had this discussion one time with Ilya, the CEO, and we were saying, okay, so are you writing a native smart contract or a Ethereum smart contract? And Ilya was kind of like, well, both are native, actually, if you think about it. So anyway, if you didn't know that, you can throw your Ethereum smart contracts on Near in this thing called Aurora. I personally think that Rust smart contracts are awesome. Proximity is a really amazing kind of, it's like part like we're DeFi focused, we have a lot of that knowledge, but then also like R&D. And so today we're going to be talking about chain signatures and cross-chain DeFi. So cross-chain DeFi is definitely increasingly important. Let's show a few like charts going on here. So here's some bridge volume. Sorry, thank you. Here's a couple of shots from some DeFi like metrics happening recently. So DeFi Llama has this for the past, since November. It felt to me like the bear market started to kind of turn around by then, which is nice. We have another one here of just like the swap volume, as we can see. What we're also realizing, especially now, like all together, is that bridges aren't exactly what we were all kind of hoping would happen. So now is a great time to really like dig into other aspects. Why do I say that? Well, there's been just a couple of bridge hacks that were fairly substantial, and these sort of like keep happening. And then this isn't like throwing shade on anyone. This is just like a very difficult space to be in. Some of the smartest people sometimes like accidentally have hacks. So this is just something that happens. Here's a few more examples. 2 billion in 2022. That's quite a bit. And then now we're seeing all these different kind of bridges. Like second one here is the CCTP, right, from Circle, which is a big deal right now. And USDC is like native USDC is also like coming to Near, so this is important. So you can see kind of like the different logos here of like who's like involved, but it's almost like there's a subset, and so you almost like have to be in the icon list essentially. So that's a little bit of a problem. We have some inconsistent UX happening too, where the bridging speeds may vary. So for instance, you can use the Rainbow Bridge from Near to bring like to bring Ethereum tokens over to Near in minutes, but then going the other way is going to be much longer just because of how things work. So it's harder to explain to people like, yeah, that one will be fast, but then the other route is not going to be as fast because blah, 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 security is extremely important, right? So this is bringing that kind of like strange UX, and then of course the gas token management has always kind of been a problem here. So yes, programmable MPCs is a crucial addition. So this is multi-party computation, and man, I thought I had some idea about how cryptography worked, and then I was listening to people who actually know how MPCs work talk, and it's like, it's really pretty incredible. It's a way where like multiple people can have their own private keys, and then as they all sign it, then you can kind of generate like, this was essentially from this public key without really creating like a private key that's vulnerable or anything. So this is really what we're leaning into right here. A couple of big names that we're looking at that we're really excited about here. All of these are things that we discuss internally almost every day at Proximity. I'm sure we're familiar with these. Then we have account-based and deposit-based. One thing that I will note is like, actually, yeah, I'm very excited for this ETH Denver because EIP 4337 just got a security audit like 3 days ago. I like read through it. I'm extremely excited. What this means is that for Ethereum, we will soon have like not just your EOA, but you're gonna have a smart contract on your EOA, right? And this is a small distinction that I didn't realize was that amazing until I went to Cosmos and I was just stuck with this EOA. And I'm like, where's my contract, right? So Near is really interesting. I own Mike.Near, and every person that owns like a .Near account basically can have a contract associated with it. So you always have the option to have a smart contract on your account. So I did want to point that out because it's a huge superpower, and I really look forward to seeing this happen in Ethereum. I think it's going to happen like this year. Key advantages. Yes, so this MPC has several advantages where we can just support all chains, including the non-smart contract chains. Because essentially what we're doing is we like to have our starting place be at Near, right? Where I have Mike.Near, and I can add and remove keys as I wish, which is pretty amazing. You're not stuck with one EOA key. If you think for some reason that like, uh-oh, some person ran off with my laptop, I want to rotate my key out, you totally can. And so we're going to start with Near, but then as soon as you sort of get that whole MPC flow going, you're just broadcasting a transaction to any network. So it doesn't have to have a smart contract. This can definitely go to like Bitcoin, right? For instance. And then, yeah, we're gonna, as we sort of like make this flow for kind of chain signatures and cross-chain DeFi, like as we build out this flow between relayers and MPC nodes, then people know what to expect. We're not gonna have that inconsistent UX that we were talking about earlier. Okay, yeah, so threshold signatures controlled by Near. So this will be one of the things that we show, and then we're gonna show a couple of different sort of variations here. But yeah, you're gonna have your Near account. So for me, this is Mike.Near, and I'm just gonna sign it. And we won't get into the details. This is sort of like in the documentation, which will be on the last slide. But you can basically say, I'm gonna sign this. It's supposed to go over there. And then now you're gonna have these MPC nodes be able to just all join together and broadcast to this different network. And here is a nice little snippet of what you can expect of just signing a node. And as we say here, initially it's ECDSA and then ED25519. This guy is easier to like extract the public key, and that's what Ethereum uses. So we're going to do that. So it's pretty simple. Main focus being like multiple curve types, and then of course the derivation. It'll be almost similar to like hierarchical derivative paths in a sense. Like you can say this is supposed to be associated and going to like this particular network. So here is kind of like the first diagram that we can show of how this can work is my Near account, Mike.Near, will be initiating a signature, and then we're going to go off to a few different MPC nodes. And these validators essentially will sign the payload via MPC, and then, as I said, we will be like routing that to the destination chain. Now let's talk about the gas relayers, and maybe putting a little pause in this. So NEAR does have like meta transactions, basically what you're used to in Ethereum, and so we can kind of talk about this a little bit as well. So here I am, Mike.NEAR, initiating a signature. We got the same sort of flow going to the MPC nodes, and then these validators use the MP, all joined together for the multi-party computation, and then we have this multi-chain relayer. These relayers, how we got meta transactions working was, remember how I said that like NEAR has a remote control of several different buttons where you can add a new key, you can remove a key, and I can create like aloha.mike.near, that's called a sub-account. I can delete my account if I want. So there's several different buttons. And so what we did to make these relayers possible was we added a new action, a new button to our remote control on mike.near saying like, I want to delegate an action. And so these relayers are kind of using that, and then we will obviously pay relayers for their work. And then the relayer takes payment, USDC. We fund the destination address with gas tokens, and then boom, we just send the signed transaction. And here you can see that we're sort of targeting Bitcoin, obviously Ethereum, Solana, and Atom too. Use cases, yep, so AI Phi, which we've been talking about a lot today on the stage actually, and then the Omnichain AI Coprocessor, which is quite interesting. This is basically like a custom way to like execute difficult computations that AI likes to use, basically. Trustless bridges to all chains, including non-smart contract chains, because again, we are just talking about broadcasting in this sense. And yes, so all kinds of things inside of AI Phi. Swaps between AI tokens. BitTensor is a big deal right now. It's the TAO token. I'm sure folks who are into AI have been seeing a lot of posts on crypto Twitter about this as well. Lending using any sort of AI tokens, restaking, and that's probably going to lead us to our next little diagram here. And actually, yeah, we'll show more about the coprocessor stuff here. Trustless bridges. And yeah, we can have a light client to NEAR and decentralized MPCs that handle kind of the other direction. And again, of course, we already have Ethereum, and that's been working for a very long time, very well. Here's the diagram, and it's going to get a little busy, so I'll point out what all the arrows are doing here the best I can. So here, let's say I want to have a token marketplace. I'm the seller. I can say, all right, I'm going to deposit some generated deposit account. Okay, down here. Our buyer is going to also deposit USDC. As I said, that'll be native on NEAR. And we're going to actually kind of directly deposit the TAO, which is the what we were talking about a second ago, BitTensor. This arrow probably is going slightly down to the marketplace as well, but then we're going to have this interaction between the seller to the buyer. Hey, do you want this thing? Buyer to the seller. Yes, I want this thing. And then boom, now we just kind of have that transfer happen. So this is just kind of a hopefully easy way, instead of imagining, to kind of see how this might operate. And yeah, we have developer docs in terms of like how this chain signature is working, how the MPCs are working. There's full directions on how to like set up your own sort of Cloudflare worker and all this jazz. Set up your own relayer. Telegram group is over there. And yeah, there's a lot of people involved in this who are walking around ETH Denver. We'd love to talk about it. And yeah, if you haven't tried NEAR, I'd love to like talk your ear off about it. It's really pretty incredible. Cool. I guess we can open up for questions if there are any. Yeah, that's a good question. So actually, I'll go back a little bit. And I believe this is, so you're talking about this kind of this bottom part here. Yeah, so I believe that this is like, for people who already are kind of starting on Near and maybe they want to get into some sort of DeFi protocol that is launching, but they're just like, whatever, I don't want to deal with like having native tokens over there. I just want to do it, right? And so the relayers are like, hey, I have native tokens for all of the things. So then it can just kind of help you get started. I get the sense that people who are showing up to ETH Denver at the hackathons, maybe they already have, an Ethereum account funded, a Near account funded, but I believe that the relayers are kind of like for this use case where people like have nothing yet on one of the sides of the networks. It's a good question. You still need what? Yes, and so the relayers are taking USDC and they have some market rate, I assume, right? Being like, well, I'm going to charge this much, and then you say, yeah, I'm willing to pay that, and then they're like, well, I'm making a little bit off of you, but I'm also doing you a service. So is that kind of clear? The idea being that it's USDC, but yes, like they will be the ones kind of determining like, I'm willing to relay this for you for this much USDC because of the prices at this moment. Yeah. Yeah, and I think this is going to get really interesting because in my kind of opinion, and I'm going off script here, but like I think that there's a couple different ways we can do this, which is like you can sort of have NPCs all come together and like sign a transaction and just straight up broadcast it to an RPC. But then if we fast forward to a world where there really is this cross-chain vision happening and there are intents and AI agents that are like solving things for you, then there's gonna be like all this traffic flying through, and I do believe that maybe like having the proper nonce is gonna be a problem, because it's like two AI agents from things that you set up 6 months ago happen to try to like wanna do the same thing at the same time. And so besides like the NPCs coming up with the payload and then broadcasting it to the network, it's possible that we can do something more like 4337 if we desire, or experiment with it, where we can sort of sidestep the nonces, and we can just say, we're just simply passing a message to this other blockchain. Hopefully you're passing a message. Hopefully, I would like to pass a message from Mike.Near to my smart account on Ethereum. I would love that, because then my smart account can say, okay, yes, I will do something here, no, I won't do something here, have different conditions, or yeah, and then you sidestep nonces completely. But anyway, like that's probably like down the road, but this is sort of the vision, is like, let's just start with like broadcasting stuff to other networks and make this like, just like normal, like where you know what to expect and you don't have to like spend an entire afternoon being like, wait, hold on, so what do I do with the UX again? Like it should all just be pretty standardized. So pretty exciting. We don't have a demo on this quite yet. I believe the Pagoda team will, and we'll be doing a lot more of this in ETH Seoul as well. So yeah, any final thoughts? So I think in this case, I guess like maybe the simple example that I'd like to think about is like the Bitcoin address, where like, so I have Mike.Near, and I think I may have missed an important part that confused me too. So maybe you're in the same spot that I was, which is like Mike.Near can go through the MPC and then basically like derive a Bitcoin address, right? So I would never be saying like, hey, I have like this one, I have like a ledger account that has like a 1 BTC on it. I want to like link that to my Mike.Near. That's not how we're thinking about it. We're thinking about it like you'll be able to derive a Bitcoin address and then just straight up like broadcast to the Bitcoin network. And then now maybe I decide to like move some of that over to there. Does that make it a little bit easier? So the starting place is Mike.Near, right? Does that help? So you're almost like generating a brand new one, essentially, but there is no seed phrase, right? Because it's all kind of behind this MPC math that is still blowing my mind. Yeah. That, yeah. I believe that the left QR code is going to have this stuff. Yeah, because there was some pretty critical documentation that was like merged like in the past like week. So I'm getting up to speed about this, but like it's there and there's like repos and stuff. But in terms of like how do I go through each and every step, I think that the relayers though are extremely detailed. If that's another starting point, my friend. Yeah, so it is all based on the threshold. And that, I'm not gonna be able to speak to the technical side of that, but I do believe you can say like, yes, we would like to have 5 out of 6 people say, sign off on this, or like, no, like whatever, 2 or 3 is fine or whatever. But yeah, threshold is how this is accomplished. Awesome, well, thanks everyone, and look forward to chatting this week.
You ready? I think we got about 5 minutes.
I was born ready.
Awesome. So make sure you use the mic.
Okay.
We're recording it, so that'll
Yep.
be the audio in, and then this will advance your slides. If you go too far, you can always go back.
Awesome. Easy button.
And I think
2 buttons.
laser point works. Yeah. So if you want to laser
If you
point anything,
yeah.
you're welcome.
If you mess it up, it's your own fault.
Yeah. Exactly.
All right, hello everyone. My name is Jeffrey Cannell. I'm also known as Emozilla out there on the wide internet and the Twitters of the world. I'm the co-founder of NOUS Research, and this is a little talk about how we are trying to make an open source GPT-4. All right, so a little bit, you might know about NOUS Research, might not. What do we do? I like to tell people we're basically just kind of like the homies on the AI Discord. We started out as a bunch of people talking about how we can make open source AI models not suck. And this is back when they sucked considerably more than they do today. And we would just get together and be like, hey, I noticed you're working on this, I'm working on this. And out of that came a group of models known as the Hermes models. And the Hermes models are probably, I'd say, the most used open source AI models that are out there right now. Have like tens of millions of downloads, and we hear that they're used in all sorts of cool things. And the thing about the Hermes models that make them like different from what you're going to get from like a llama model or something like that is that it doesn't really like patronize you, right? It does exactly what you want. And this is sort of when people talk about alignment in AI, it's kind of an interesting thing because often, and we've seen this now with like the release of Gemini, that sometimes the model is trying to align you and not the other way around. So what we do at NOUS is we make open source models that everyone can use and open source AI tech, and we do it in a way that we think is pretty fun and unique. So what is the actual problem that we're setting out here to solve? It is, what is the best open source model? If I asked you that and you were someone who wanted to like go download some open source models and use it, and I said, hey, well, which one are you going to use? You'd probably think to yourself like, well, what's the best open source model? And you would have a difficult time answering that question. And in fact, the best way you'd probably answer it would be to like go on Twitter and be like best model and see like what people are like talking about. But that's not very quantitative. And the reason for this is because well, oh yeah, I forgot. It depends on what the meaning of the word is for all the people who grew up in the 90s. And so let's talk about the good old days of AI, the good old days of AI research. Back in the day, you know, the only people working on AI models were sort of at like academic research institutions, or they were at companies. And what people did is they were really nice and they made these like benchmarks that you know, you could compare against. And what would happen is you would train your little model and you spend all your time working, and then you'd maybe publish a paper, and then you would submit your model to this organization that maybe would then go and benchmark it, and they would come up with some results, and they'd post it, and it would be super official, and everyone in every paper would quote the same model score, the same benchmark scores, and all of them will have been evaluated the same way, and it would have, and what was really nice about it was everyone sort of agreed not to cheat. And this was a very important piece of the whole puzzle, was everyone agreeing not to cheat. And this came out of the fact that, like I said, most of these were put out by, you know, quote unquote professional organizations, and they would have, you know, if they cheated, they would get the proverbial academic finger wag at them, and so they didn't. And so we would end up with nice things like this, which was the super glue benchmark, which is where you could go and say, oh, I see, this is the best model for this size. And it was very easy, and everyone was happy, and all things came along. And then something happened about a year ago, and that was the proliferation of all the open source models, which was good. But what this did was it created a bit of a perverse incentive. So no longer were there these big gatekeeping organizations that you had to submit your model to, which is good. We're all fully in favor of open source and creating disintermediated and permissionless systems, which perhaps we'll come back to later. But what this led to was the proliferation of what is known as the Hugging Face Open LLM Leaderboard. And the whole Hugging Face Open LLM Leaderboard is where you can go and submit your model, and it gets evaluated on a series of benchmarks, which are basically, you know, tests that you can run the model against. And you'll remember my previous assertion that a lot of the old benchmarks relied on this thing where everyone agreed not to cheat. And we sort of no longer have that arrangement. And we are praying that it is not changed any further. And the reason for that is because as it stands right now, getting to the top of the Hugging Face LLM leaderboard is like, you know, an accomplishment. And it is an accomplishment, right? Because it is difficult to do. But when your sort of only incentive to do this is to like, you know, see your name at the top, you may be inclined to take some less than savory measures to get your name to the top. So all of these, tasks here are ColorSwag, MMLU, Truthful QA, and so on. The test set for them, the questions that are being asked for in this leaderboard are open. You can download them and see them. So suppose you were someone who wanted to like get some notoriety and wanted to get your name to the top of the LLM benchmark, and you knew exactly every question that was going to be asked of your model in the test. What might you do in this situation? You may be inclined to go ahead and start training on all of the test questions. And this is like, okay, like it's, first of all, it's you know, it shows that transformers can, you know, learn and that the models work, and your score will go up. But if we go back to like this over here and then say, what is the best open source model? Do you think that the model trained totally on test questions and only on test questions, gets the highest score, is likely to be the best open source model for you? And the answer is probably not. So now we have this problem where like you as the user, person trying to create agents who are trying to fine tune a model to do some downstream task, don't really have like the information that you need to know what the best model is. And all of this, if you think about it, is really just a downstream effect of the incentive structure, right? Everything in life sort of takes its path of least resistance, right? And if the only incentive that you have is getting to the top and seeing your name at top, then that is the behavior that you are, whether, you know, it wasn't on purpose. Hugging Face didn't mean for that to be the case. And like what they were doing, what they do is like fundamentally good, and it's like not bad in any way. But when that's sort of the incentive, everything just sort of flows naturally in that direction. And that's where we stand today, where it's very difficult to know what the best open source models are. And so at NOUS Research, what we believe in is like disintermediated access to local open source AI. And so because we believe in this, we actually have to like be able to tell people, how should you know which models to use? And furthermore, not only just answering that question, there's the larger question of, can we develop some mechanism so that the behavior that we want, which is the creation of the best open source AI models, can we make it so that that's the actual path of least resistance? Because that's the thing that will actually create the result we want, right? The people I say, show me your incentive, I'll show you your result. Well, that's sort of where we stand now. You've probably seen this before. It's a little bit of like a trope, right? It's Goodhart's law. It was actually formed originally by this much more technical thing where he says any observed statistical regularity will tend to collapse once pressure is placed upon it for control purposes. But what this means in a little more plain English is that when a measure becomes a target, it ceases to be a good measure. And that's where we stand today with a lot of like the open source benchmarks. And so out of that, we sort of asked ourselves, is there a way to do this better? So what do we want? Like, what are we actually trying to get? We thought a good goal, like a noble goal to start out, would be an open source GPT-4. It's not perfect. When I say this to people I say like, why stop at GPT-4? And this is a fair question to ask, but my reply to that is always, let's get an open source GPT-4 that everyone can use, and we'll go from there. We'll go from there after, right? Like we're trying to create some achievable goals that will meaningfully make open source AI better for everyone on the planet. And so for it to work, we need it to be permissionless and decentralized. We are not sort of in the business of, you know, creating a model behind closed doors that's the best and then, you know, dumping it on the world. There are organizations that do that, and the few that have the resources to do that right now from the pre-training perspective are doing the Lord's work. But that's sort of not kind of where we grew out of. We grew out of Discord, we grew out of Twitter. A lot of us have crypto backgrounds, and that wasn't sort of our ethos that we did it. So we said, is there a way to do this in a permissionless and decentralized way? And really the strategy, like I echoed a second ago, was that the strategy is make people want to do the thing we want to do. I know that sounds like groundbreaking, right? But like, if you could solve that problem, you've solved pretty much every problem. So the question is, how do we make people want to create high quality open source models that actually are good at downstream tasks? So we used, you may have heard of it, you may have not, we used a blockchain called BitTensor. So BitTensor is a substrate chain that essentially is modeled after a deep neural net. So it creates these concepts of nodes that interact with each other in a similar way that a densely connected neural net works. In the fact that each of the nodes, which themselves are public-private key pairs, have this relationship amongst each other where they have these weights, and these weights represent like some trust or some other value between them. But what's interesting is that like if you think about a deep neural net, like basically every node is connected to every other node and has their own view of what they think is the correct value for these weights. And then the network as a whole sort of comes into consensus and says, well, everyone thinks this, that, this. This is sort of the, it's not really the average, but it's the way that the network as disparate pieces are coming together to consensus on what how all these nodes should be interconnected. The thing about the way BitTensor works is that it's really kind of just like a springboard platform for these things called subnets. And subnets are basically the actual application layer built on top of BitTensor. And in that subnet, in that application layer, you as sort of the subnet designer are able to create whatever incentive mechanism that you want to. So it's kind of like, in the same way that you've probably seen other, Avalanche, for example, has like subnets too, right? Where you can basically create your own rules for the way like the EVM works on. In a similar way with BitTensor, you're able to design your sort of own incentive ecosystem on top of this design space of having these interconnected nodes that each all have these weights together. So we created a BitTensor subnet and with the goal of creating an open source GPT-4. And so that is what we call subnet 6. Very, creatively named because it's the 6th subnet. Actually, what's interesting about the subnets is they exist in like competitive space. So there's only 32 at a time, and like whichever one people are using, the top 32 that are like used the most, basically, are there. And then if someone else comes along, then you can like outbid someone to be one of the 32. So how does subnet 6 work? The way subnet 6 works is that models are submitted to subnet 6 by miners. Now, we can use the phrase miner here. It's funny that like all things that are old come new again. You know, we had the days, 7, 8 years ago where only, ETH people were buying every GPU on the planet to like mine ETH. And now every AI person are buying GPUs to like fine-tune models to then get crypto again. So it's fun that we brought it full circle. But the models are fine-tuned and created by any mechanism that the submitters choose. This is a key piece because it actually becomes like a technical competition. So the models are submitted to subnet 6 by the miners, and what we do is we take data from a different subtensor subnet, which is subnet 18, and what subnet 18 is doing is it is constantly calling the GPT-4 API with novel questions and instructions to generate brand new synthetic data all the time. And this essentially is like the key piece that's the differentiator, which is that rather than having this fixed test that anyone can cheat on, we use the incentive mechanism of BitTensor to fund the creation of new synthetic data all the time, 24/7, 365. I guess, just lining Sam Altman's pockets, I guess. But, we're constantly calling it all the time and generating new synthetic data. And that new synthetic data has never been created before, right? Like it's brand new. And because it's never been created before, we can use it to evaluate the models that are submitted onto subnet 6. The data is completely fresh, completely new. You can't train on it and you can't cheat on it. And so what we've essentially, the thesis is that if we can make an AI model that in every aspect mimics the way GPT-4 responds to questions, and these questions all have to like, be novel. They have to cover like the entire space of all knowledge, which obviously we aren't doing it perfectly, but there's been a lot of research into how to do these eval and struct methods so that you're always generating like new questions, and you do like these like almost like a Socratic dialogue with the questions themselves to generate new questions. And so out of that, we're able to create this brand new data that has never been seen before that we can use to evaluate the models that are submitted to our subnet. And then validators on the subnet test the new data and get the loss, which is basically like a measure of how close the model was to predicting what the actual text was. So basically, pull back curtain a little bit, LLMs work by not actually predicting the next token, but predicting the probability of all words together. And they assign to every word in the vocabulary a probability. And then you use something called a sampling method to like pick which words to use. But because of this, you can actually create this measure of like how close was the model towards the output of what GPT-4 said it was going to do. And so what we do is we then take this brand new synthetic eval data and we test and we create basically like a winner and loser. It's a competition to see who can get the lowest loss, because you want to be as close to GPT-4 as possible, who can get the lowest loss on the brand new synthetic data. And then what we do is we take the emission mechanism that's inside BitTensor and we redirect it directly to whoever submitted that model. So now what have we actually done? We're saying if you are able to submit an open source model that's better and closer to GPT-4 on this constant synthetic data, then like you're incentivized, you're earning tau all the time for doing it. And what it means now is that we've correctly incentivized the behavior that we wanted, which is not benchmark chasing, but which is actually creating better open source models. So this is, I guess this, the screen didn't show so far, but this is like a log print of like constantly generated new synthetic data. So all the time we're constantly being, and I guess you can't, yeah, it's hard to read. If you have a nice screen, it's easier to read. But yeah, I can see here, deliberate on the ethical considerations of medical experimentation on animals in the advancement of human medicine, and discuss the effectiveness of psychedelic therapy in treating mental health disorders. So like, it's just this constant like stream of all these different questions. And it's got like, this is the whole like tree of like concepts, and you have ways to like ask it to refine the question. And then finally we take all of that and we ask it to GPT-4. And so this data, the answer that just like came hot off the presses from GPT-4 is what is we're constantly reevaluating all the model submissions on to then determine which one was the best one. So this is what the leaderboard looks like. It is hosted on Hugging Face as well. It's a Hugging Face space. And so this is the Subnet 6 leaderboard. You can see it. I have a QR code for it later in the slide too, if you guys, to get to it. So this is an example. You can see here some guy named DeepNet is winning the competition as of when I was on my flight over here, because I totally didn't make these slides on the flight over here. And you can see that he's winning, and he's just a public-private key, all right? I don't know who this guy is, but he's making better open source models, and so we're gonna incentivize him to do that, right? And so this is the leaderboard here for our Mistral 7B competition. And what's nice about the leaderboard is it also shows you for these competitions, it doesn't just say this guy won. We'll say here's an actual like example of the output that it generates. So we generate a bunch of example outputs as well. You can see how it works. And these models really are becoming really, really good because we've incentivized people to get their, to create models that are as close to the GPT-4 outputs as we can. And what's been really cool to see is that, people in the AI space, which, to be frank with you, sometimes have like a bit of an antagonistic attitude towards people in the crypto space, have really seen that this is something advancing the state of AI by using permissionless, decentralized protocols to like move it forward. And that's something that like resonates. I mean, most people will, give you the sort of like the smell test, I like to call it, like, does this smell funny? And to many people in the AI space, this does not smell funny at all. And that's awesome because it shows that crypto's fundamental value proposition, which is, disintermediated permissionless interaction between agents, is something that will resonate, And so we've been really excited about the uptake that it's had. It doesn't hurt that we're giving away a bunch of money too. That always helps. But within the broader space of is this advancing the state of AI? We feel that it is, and we feel that we're, by using these primitives, we're able to help show that they can, have meaningful results. So to give a little bit of a one-liner, subnet is an experiment in using crypto primitives where it makes sense to incentivize the creation of high-quality open-source AI models. We have 2 active competitions going on right now. One, which is the one we launched with, which is fine-tuning Mistral 7B, which is a 7 billion parameter model, probably the best 7 billion parameter-based model put out by a company called Mistral AI, based in France. And then actually just today, we launched our second competition, which is to fine-tune the Gemma series of models, which was released by Google a couple days ago. This is actually a 2B parameter model, which at 2 billion parameters is more focused on like edge inference. So you can run like a 2B parameter model on your phone. And like totally, you're not connected to the internet. You're not like, I mean, you could go turn on, airplane mode, and that AI would the AI model would still work. And so we're also redirecting a lot of our incentives. Right now, we actually have it as a 2-to-1 weight for the new Gemma one to help get that competition going. Because we really think having like a GPT-4 that you could, it's not going to be as good as GPT-4, but it can approximate GPT-4 in 2 billion parameters on your phone, completely owned by you, not touching any SaaS API, anything like that, is something worth, striving for and building in the open source community. So that's what we have. In last month, we gave out over $2 million directly to open source AI model creators. And that is not a typo. That is $2 million a month that we're using for. So we're really like, we're aiming the cannon of how can we advance this. Thanks, appreciate it. So like this guy right here, he's big. What? It is from the native emissions of Tau. So the BitTensor Tau subnet, basically, we as a subnet get like 7% of the Tau emissions globally. And then we basically take all of that and redirect it towards the people who can create the best open source AI models. And to go back again, these people on the left over here, these are all open source models that you can download directly on Hugging Face. But the people who made these, I have no idea who they are. They're public-private key pairs submitting on a permissionless network that I don't control, that like don't care who it is. What I do care about is that you created a better open source model that everyone can use. Yes? So yeah, so these are all on Hugging Face, and the weights have to be able to be downloaded directly. So that's kind of like the key piece. Is what happens is they actually submit, they sign a message on chain with a link to the Hugging Face model download. And then the validators themselves have no credentials. So they actually have to be able to go download and get the model, like as a, there's no trusted, the validators themselves have no trusted access to the models. So they have to be posted publicly so that anyone can download them and be available. And so, because that's the way that we just do, the validators just do like an anonymous Git, poll to get what's on there. So it has to be publicly accessible and open to everyone. So all of these, all of the models that are being created and submitted within it have to necessarily have to be open access and be able to be downloaded. So this is, if you run it real quick, this is a link to the leaderboard that I just showed you. So if you want to get started in maybe making your own model and doing this and learning about fine tuning, no longer do you have to kind of do it for fun, but now there's there's a profit motive behind it as well. But we find that in a lot of things in life that will direct things towards the outcome that we want. So that is a link to the leaderboard that I just showed you. And so just to close a little bit, at NOUS, we're really all about open source AI access, being able to disintermediate the access of this powerful new technology to everyone on the planet. So this was has been a very exciting experiment. Like I said, a lot of us came from crypto backgrounds, and seeing how we can use these crypto primitives of permissionless, decentralized interaction between trustless agents it's been awesome to see, and I look forward to how in the coming months, we're going to be able to take this even a step further. So this is really just the start of what we want to build, and we're excited to see and to show off eventually where that comes. So you can follow me on Twitter if anyone's interested. I'm at the Emozilla, not just Emozilla, but the Emozilla is me. or you can follow us at NOUS Research. Or if you want the best way, we grew out of the Discord, I like to say. We came out of it. That QR code is an invite to our Discord. So you can join in. And what was originally like, a couple dozen people just talking about it 9 months ago, we now have like thousands of people working, and we have tons of different work groups of like people sharing their ideas of what they're working on to create the best OpenAI access models. So you can join the Discord, and we're also all on there too. So yeah, that's Subnet 6 and what some things we've been working on at NOUS. Thanks. I think probably have like 5, yeah, it looks like we have like 5 minutes for questions or if anyone wants to talk. Yes. How do we keep synthetic model generation? Oh, yeah. So, so that is it is an interesting question. So one of the co-founders of NOUS, his name's Technium, is like kind of like the world's, like, I wouldn't say expert at it, but he's one of the best people in the world for it. Really the fundamental thing is the eval methods, so it's not just here are the questions we're gonna ask, but you actually ask GPT-4, give me some questions about this topic. And then you say, okay, for each of these questions, what are like some arguments for it, against it? What are like some interesting details, connections? So you actually you don't just start with like the synthetic data, but rather the questions themselves are synthetically created by GPT-4, and then you take those questions and then generate the answers to them again and use that as the eval data. So it's not perfect, and we are constantly like evolving the synthetic pipeline to make it better. But so it is really like we're approaching it on the synthetic side. But what we know in AI is that like the data really is everything. The data really is everything. And so it will be as good as we can make that synthetic pipeline. But the Hermes models that people use is almost 100% synthetic data. And that's been proven to be like wildly popular. And this is interesting because there was a question not long ago whether synthetic data, like whether it was like kind of reductionist, whether like synthetic data would like, can you actually make a model better by training on like a model outputs? But we've definitely seen it to be true. Yes. Yeah, so that was done sort of by purpose, I guess. We really want to make like 1 or 2 best ones and make it competitive. So we actually take what we do is we take each of the models, we compare a win rate against each other, and then we do like a softmax on it. And then from that, it like pushes the distribution close to create like a top 4 or 5 one. We split it up with the new competition. Basically now there's like, I guess you could say like there'll be like 10 or 11 winners that are like going to be getting like a substantial chunk. And we're going to keep iterating new modalities and new competitions. Because really we want to we have the ability to focus these incentives into making open source AI better. And so we kind of want to aim that, for lack of a better word, aim that cannon at all different sort of aspects of the pipeline. We're also looking into doing can we make a model that's really good at math or at a specific downstream tasks and stuff like that too. So that's where we're going to be evolving it over the next weeks, is just constantly pointing it at different modalities and see if we can create SOTA models from that. Yes. Mm-hmm. 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 Yes. Well, I would say actually, this is actually really for all of the quantitative mechanisms, what we're trying to do here, you will still find that I always tell people a tool's a good tool when you reach for it when you have a problem, right? And so, as people use the models that are coming out of it and they're finding them useful, that's actually the actual real done. But the fundamental thesis is that that GPT-4 is very good, which it is. And so if we're able to approach the GPT-4's outputs as close as possible, we will be creating a model that is useful to them. So that is the fundamental thesis underneath it. And so it's not perfect. And like I said, we want to, in open source, go beyond just that. but this is a good starting point. On the alignment side, I think the alignment question is like so big, it's almost hard to like really like break apart, because often the question is like alignment to what, right? I mean, all of these models exist in like this infinite, almost like infinitely sized possibility space, and almost all possible text that's ever been written, right, is like in the possible outputs of it. And so for this particular project, because we're using GPT-4 as like the baseline, we're not directly tackling it and trying to do that. I mean, we're really just trying to be like, can we create an open source model that is good at mimicking how GPT-4 works? We were not stopping there. We're by no means limiting ourselves to there at the NOUS, but specifically with this project. And that comes down to the empirical ability to like do the comparison. And that's really the problem with all of it, is like, how do you do an empirical comparison of like vibes, basically, right? So we know that people like GPT-4 for some things. So if we're like, well, we can at least get close to that, then we're getting somewhere. So, yes. Yes, so we have a bunch of like, there is one of like the 80 different like subtracks is like, write me a Python program to do this, and write me a Python, or like solve it using, and it'll come up with these weird ones where it's like, write a Python algorithm to find the longest subsection of 2 characters that doesn't contain the word dog, unless it contains the word dog. Then, like, you know, these like really kind of like weird sort of constructions together. Because really what you want to do is, in the synthetic data, you want to touch all of the latent space that GPT-4 covers, right? Yeah. Yes. Yeah. We don't. I mean, the answer is we don't. And I would not in any way claim that this is creating like the best or greatest models that are out there. It's really more about, can we use the existing mechanisms, this incentive mechanism now, to take what was something that was totally misaligned with what the community wants, which is benchmark chasing, and redirect it towards something that is more useful. And I always say, like, better yesterday than today, better tomorrow than today. And if we can do that every day, then we're driving like the space forward. Yeah, yeah, sure. Yes. Yeah, yeah. Mm-hmm. Yeah, well, this isn't directly a benchmark. It's loss against GPT-4 synthetic data, and that's a different thing, really, because benchmarks before would be like, ask you a question. It's very much the SAT, right? Ask you like a complicated question, A, B, C, or D. What's the right answer? And then if you pick A, like you got it right. Whereas what this is actually doing is, it's like at every word, the loss is calculated over the entire output of the text. So what it de-emphasizes is like absolute correctness for a specific answer, whereas like a benchmark is like, did you get the number right? And this much more highly emphasizes being able to cover like the entire, the expressive space of the way GPT-4 reasons about problems. So you sort of like get chain of thought. You get all of that stuff that's baked into GPT-4 like for free, because your loss is calculated at every token as you're going along. And then it's summing that up together to get the lowest loss. So it's very much like not trying to score highest on the answer. It's not trying to score highest on the test. It's trying to talk exactly like the teacher would talk at every moment. But like, if you can talk exactly like the teacher, then like you would give the right answer to the question, you know what I mean? So it's very much like a different paradigm than you get from like the previous benchmark stuff that was done before. But I think I'm over at 5, so I'll be hanging out around too, and be sure my DMs are open, a stupid thing to say or whatever. So go ahead and shoot me a message, and love talking about what you're doing. So appreciate it. Thanks.
Thank you, Imo. Really appreciate it. Imo will be hanging out outside there to give hang out with everyone. We have our last keynote for tonight. Today actually is from Modulus Lab. So welcome to the co-founder of Modulus Lab.
Hello, everybody. Oh my goodness, great. I'm not as tall as the last guy, so maybe we'll do that. All right, we got a smaller, more intimate crowd, so feel free to filter to the front. I don't really have a presentation. I thought to just make it more interactive, which is my way of saying I didn't prepare anything. But I like to think that I have a really charming personality, so maybe we can start there. Really quickly, can folks who know about Modulus or just anything that we do raise your hand real fast? Okay, we got like, got like 3 or 4 people. All right, that's pretty good. All right, cool. Modulus is a zKML company. Who here knows what zero-knowledge cryptography is? Okay, a couple folks. And obviously machine learning, I think, probably a bit more intuitive. Well, canonically, zero-knowledge cryptography, really quickly, is generally used to prove that some computation occurred without manipulation, right? And so a very kind of contrived example, potentially, is to apply that same principle to machine learning and go, okay, when I query GPT-4 for a response, the response I get actually did come from GPT-4 and not from GPT-3.5 or GPT-4 after it's experienced a couple of downgrades. And of course, this might be relevant because that seems to be what have happened in the past couple of months anyways. We've had this like fluctuation in LLM performance. And the whole kind of premise of Modulus is predicated on a future where models both small and really, really large kind of grow to become a really important part of just the compute stack of society at large, right? And so suddenly it becomes really important to know that actually I am getting the result that I think I should be from the model that I actually want, right? And today, the only people who really give a shit about this live in crypto because we're like really paranoid about like, oh fuck, somebody's gonna like mess with my my AI feature. Someone's gonna mess with the way we evaluate risk for insurance or for pricing. And so all of our customers that pay us are in crypto, and the people who don't are not, which is interesting. So that's kind of what Modulus is at a very high level, right? We work with companies like WorldCoin on privacy, with Upshot on AI pricing, with Ion on AI risk, all of which is used to enrich kind of the Web3 environment. Although, of course, the ultimate aspiration for the company is to go into the world at large and improve things for everybody. And I'm very happy to talk about literally any of that. There's a lot to cover. But maybe we can just go for what folks might be more interested in learning about. How did I, somebody who looked like they're 12, end up working on this? You know, what do we think the future is? Those are some lovely companies. Which ones I think are real and which ones I think are not. Yeah, what do folks want to know? Wow, just instantly trying to get me canceled. I think Near might be real because I think they're hosting this lovely place. So maybe we can start there. Ilya is definitely real. I can tell you my favorites. How about that? I really like the folks at Jensen. The model or the value prop is very simple if you're not familiar with them. You know, how do we get latent GPUs to contribute to model training, which is something that's probably going to be in more need in the future than it is right now. And the way to do it is also through cryptography. In fact, we have a lot of research parallels. Harry and Ben are angels in Modulus. We like to think that we make their lives easier. And we like to think the opposite is true as well, of course. So I quite like Jensen. Technically, I'm an angel investor in Ritual. I don't know what they do, but they're smart guys. Yeah, maybe I'll just pause it there. Yeah. Yeah, that was kind of a joke question. Yeah, although thank you for asking it. Any other questions about Modulus, zKML, the future of AI? Yes. Love that. Yeah. Yeah. Yeah, this is a really good question. I think my instinct is that, all right, my background is AI research in my whole team. We were at Stanford before Modulus, and then we were like, oh my God, PhD, so scary. So we started Modulus. So it's going to be like probably a response that's rooted in that academic background, right? Or that bias. And certainly from the perspective of AI research from like a couple years ago now, so this might be a little old, my sense is that there will be a lot of specialization, right? We're going to have these like beautiful, small, elegant, discrete models that run on the edge, right? In your local phone, in your laptops, on your desktop tower, which are really good for certain types of tasks, right? Especially those that are really sensitive to your data, right? So just to make it really concrete, we work with a company called WorldCoin that's trying to process iris data, so your biometrics, and they want to do that on the phone without sending your data to like a server somewhere, right? And that's really difficult because whenever you want to run kind of authentication tasks on the edge, you now have to trust your users to not be running that in an emulated environment, as an example, right, with doctored data. So what we do is we prove that the model inference on the user's local device, their phone, ran without manipulation, right, kind of high integrity AI operations. And so this allows WorldCoin to be convinced that, yes, you're not pretending to be a unique other human being while you retain your biometric data. You have self-custody. If you throw your phone in the river, there goes your biometrics, right? So that's like one class of models. But in operation, it's totally distinct than like these huge like cloud-hosted LLMs that's like making inferences at a really high capacity really quickly in this parallel fashion for maybe like more frivolous but nonetheless kind of attractive tasks, right? And the models will look very different. And yes, overall, I would say models are getting bigger and more sophisticated, but with that, there's also growing interest in smaller models with quantized weights that are more energy efficient, that can run on embedded systems and things like that. So yeah, I think there will be a lot of kind of specialization. There already is in the literature, but the things that grab headlines usually are like the big models that run in the cloud. Yeah, great question though. And that's just my perspective. I might be wrong. I have been. What's next for Modulus? Okay, great. Thank you. I think this might be true. I think Modulus has built the world's fastest zk prover, which sounds really impressive until you realize that it's only fastest at one thing, and that one thing is AI inference. As in, you can't use our zk prover, or you could, but you really don't want to use our zk prover to prove like anything else. That an on-chain transaction happened correctly, that some historic state on Ethereum was queried in the right way. All we do is AI inference, right? And the reason we think that that's important is because AI inference looks very different in terms of the compute architecture than like the stuff that you traditionally associate with Web3. And so it's like, okay, if GPUs were really good for AI models and modern deep learning exists because of GPUs, can we do the same thing with ZK software, right? So that's what we've done. And in terms of what's next, it's almost the kind of hard part. Like the easy part's over, right? The easy part was to make technology better. The hard part is applying better technology so that we create more utility in the world. And so a lot of this year for us is focused on working with customers and partners on building new applications that were never before possible, but are uniquely enabled by high integrity AI. So yeah, that's a big part of the year. Yeah, honestly, I think it's going to be like better products, basically. As in, if you look at some of the kind of existing use cases that's integrating with Modulus, these are things that could not exist in another context, right? Like without zKML, again, what we work on, the WorldCoin model doesn't work at scale. You would have to take on trust assumptions, and you would have to store your biometrics with some third party, which is really scary, right? And on-chain risk, you would have to trust the kind of agency or the institution that's like assigning these risk labels, as opposed to knowing that those risk labels are always consistently applied. We're working, this isn't public yet, but with one of the major wallet providers in Web3, and they have this AI script that runs in the background that's scanning for scam transactions and taking them out of your wallet, which is great until you start to think about who arbitrates what is a scam transaction and what isn't, right? And so with our ZK proving, we can show that that AI model is always the same model that's being applied across the board, and also that that model has this validation result, this track record, this back testing, so things like this, right? I think it will be best-in-class products that ultimately move everything we work on forwards. Yeah. Yeah, it's a great question. This is a little bit of a cop-out, but it's kind of the same answer as before for me anyways, personally. I just think that for the mass consumer, right, or actually even a more niche kind of initial consumer base, the thing that ultimately moves the needle is this product is better than this other product in the metrics that I care about, and usually those metrics are costs. All right, so I mentioned earlier Jensen. Jensen's whole value prop is if training is cheaper with us than it is with AWS or G-Cloud, and it seems like nobody's getting like faulty training results, consumers will obviously choose us, right? We're much more likely to be chosen. And so I think for us, it's just like, okay, it just needs to be better, in the ways that consumers are like actually care about, right? And obviously that changes depending on the consumer segment that you want to approach. But in the case of prover marketplaces, the point of a prover marketplace is that you don't have this single point of failure where if your service provider, your cloud provider goes offline, suddenly that's it. You can't get your service in any other way, right? Prover marketplaces are supposed to solve for that. And so if it gives you that value without being much more expensive, then they will win, right? But if we look at marketplaces in the history of building marketplaces, it's really difficult because centralization just gets you to that kind of PMF iteration cycle much faster. And honestly, it is remarkably infrequent. It is remarkable how infrequently, rather, AWS goes down, right? It happens like once or twice a year. And that's kind of crazy given what they are. And so, yeah, I think, it just needs to be comparable on price and it doesn't go, it doesn't have kind of go offline. Then people will almost certainly choose it. Yeah, great question, though. Yeah. Yeah. Yeah, I think in general, I can't make it work in my head, but smarter people seem to be able to. Yeah. Well, I can tell you that, first of all, everyone who pays us for our service hides their model. They don't want to share their model, right? As in, they've worked really hard on that IP and they don't want to share it with the world. They just want to show that this model is the one that's being deployed, or the model that has all these cool features are the ones that's generating your service. And so there's kind of a value premium question associated with the optimistic approach. The other thing, of course, is okay, well, it's an open source model. Well, then I would just locally replicate it. I don't really need this strange infra around it to tell me that the model inference was correct, right? So it's either the IP is sensitive, in which case optimistic doesn't work, or it's an open source model, in which case it seems like this is a lot of scaffolding for something that's relatively easy to solve for. The final problem is how an optimistic approach generally works, at least in the blockchain case, is fraud needs to be relatively easy to observe, and then proportionally or inversely proportional to that, you would need to incentivize a watcher network to look out for fraud. But if you know really anything about machine learning, you'll know that it is tremendously difficult to notice fraud, right? These models are like black box, confusion, central, right? And even an open source model is kind of hard to understand, never mind explainability. And so to counteract that, you need a massive financial incentive to go out and actually look for fraud, right? Which is hard to architect. And then, of course, you need a large population of people to observe fraud. And noticing fraud is a deterministic process. And so whoever is most capable of noticing fraud will always get the financial reward every time until there is only one person who notices fraud. And when they go offline, fraud goes through, right? There are kind of game theoretic solutions to this. But to that, I say, just ZK it. The overhead of ZK, a year ago was 10 to the 5. Right now, it's 10 to the 3. This is all on CPU, right? My expectation is that in the next year or so, it will be 10x, maybe less, before hardware enters. And so if that's the cost of ZK, at least in latency, it's becoming progressively kind of more appetizing. And we get to live 10 years in the future, right, when we build companies. And so I want to work on endgame solutions. And to me, it feels like ZK is the endgame solution. Yeah, so the verifier is a companion piece of software to the prover. We just deploy it wherever you live, right? So, it could be in your mobile phone because you are the one who needs to be convinced that the model ran correctly. We could put it on a blockchain like Ethereum or Near or anything like that, or a data availability solution like Near, the Near DA solution rather. And we can put the proofs there. It just depends on what is the authority that needs to be convinced that the model operated correctly. Yeah. Yeah, it's a good question. Because you're right, like all of these guys, all these zKVM folks are like showing off cool benchmarks with machine learning models. So this is the way I think about this, right? So imagine a graph here. This is a y-axis, and the y-axis higher is more value, and this is the x-axis, and this is like amount of compute, right? When you're at 0, you're at the origin, 0 compute capabilities, 0 value. As you translate on the x and you get more compute capability, there's a peak in value, right? And then it comes down. And the whole point of zKVMs is to optimize for that first peak. And then, every ounce of more compute you get doesn't seem to get you much more value. But you keep going, you go for a while, and then you hit kind of basic machine learning, deep learning stuff. And suddenly the value picks up. And it's unclear kind of where that goes. Maybe it just keeps going, right? Maybe AGI is like, just more compute. But the point is that the distance between like a regular VM operations, at least in the blockchain context, and where machine learning lives, like that is huge. And it makes zero sense to me why you would build something for this regime and you would try to stretch it for that regime. My evidence for this is, if you look at some of the benchmarks these other guys put out, it's just always very silly. It's like, oh, we've built a decision forest with 3 trees, right? And it's like, look, if you see decision forests in production, they have like hundreds, if not thousands of trees. 3 trees is not helpful. Like, I may as well just randomly guess, right? And that's not a real classifier, according to me. So all that to say that, like I think specialization, if anywhere it's justified, it would be for something like machine learning. Yeah. Cool. Yeah. It's about 150x right now. So I would say depends on the model, of course, but it is hard for me to imagine like a classifier model taking longer than like 10 milliseconds. So 100x on top of that, it's about a second. Yeah. Yes, that's correct. Yeah, wait, 10 times 100. What is 1,000 milliseconds? About a second. Yeah, it is. Yeah, which is much faster than most blockchains run at. So latency hasn't been an issue for us. Yeah, that's new though. It has been an issue until about like 3 days ago. Yeah, yeah, go for it. Yeah. Yeah. Absolutely. I mean, honestly, I feel this a little bit just with like AI crypto, right? Like you can read Vitalik's blog that came out like a couple weeks on this, and you can like, at least my reading of it, it's like very clear. It's like these 2 technologies, although both very important, are just like from a personality level deeply incompatible, right? Like they have literally nothing to do with each other. With crypto, everything's like very kind of like robust and like tractable and solid, and like this is the statement I can make and no further. And then with AI, it's like this squishy mess of expressivity, right? Which is awesome, right? And you want to bring them together, and how do you actually do that in a way that honors the strength of both technologies, right? And I think a lot's been said about like content attribution and kind of like IP, and I think that kind of makes sense. If Jason asks, yeah, it definitely makes sense. But in terms of like other intersections of technology, it's tricky, right? Like even zKML, which is what we work on, like sometimes I would wake up and just like remind myself, like, does this actually make any sense? And like, I would say like 60% of the time it does, maybe less. Which is not to say it's not worth working on, because of course, like it's hard to tell what the implication trail is gonna leave us at, right? Like I think AGI is like on our roadmap, right? And like next year there will be more doctors than there are this year, and then more doctors after that. And in 1 year, there will be less doctors and less lawyers and less politicians and bankers and so forth, because models will just be cheaper and more performant than human beings to deploy in those environments. And in those environments, it's hard for me to imagine zk as one interpretation of the strength of crypto not being relevant, right? And so I think that, for me, makes this like really interesting to work on just as a problem space. But for sure, I think finding the right kind of intersections where the utility is really clear, where the PMF really works out between AI and crypto, and zk especially, is a non-linear task. We're going to make a lot of mistakes, but hopefully we get closer every day. Yeah, good question. Cool. Thanks, y'all.
Well, thank everyone for coming this Tuesday. Really appreciate for all the support. This is our first chapter for our Chain of Thought series, and we're gonna do more at both Consensus as well as Dev Connect later this year. And the last announcement from our side is, so Edge is opening up an open source campus in San Francisco. Welcome to host all open source tech in there, and really to meet more great founders like the Modulus lab, like the NOUS research there. So excited to see you, everyone, in the next one. Thank you, everyone.
And last but not least, we'd love to thank our wonderful sponsors and partners who made this event possible. So shout out to Era and Edge, Sentience, Symbolic Capital, Lightspeed, Crypto Soul, 7X Ventures. Just reading down the list, you guys can follow me. Near Foundation, Polygon, NOUS, Autonomous, Zero Gravity, Marlin, Jensen, Aura, MyShell, Humm, Ritual, Eigenlayer, KXVC, Talus, and Jutsu, and Banyan, that's my company, I left it out there. But so we're also running a hackathon. So this hackathon is started yesterday. It runs until next Wednesday. This is online, so you can still submit. There's over $20,000 worth of prizes. There are not AI bounties, or Web3 AI bounties, at ETH Denver. So this is a fantastic way, if you're interested in building the space, to continue hacking throughout the week. If you go to DevPost, you'll see it, or just follow Edge AGI on Twitter. We've been tweeting about this for a little bit. Edge is just getting started, so if you join us on this journey now, I can almost guarantee alpha later on. This is just speculation, but I think a lot of these companies will do airdrops to people who tangibly, contribute to their ecosystems, and completing their bounties is a great way to do that. And so I have zero actual clarity if that's true. It's just a vibe, given that they're all interested in Web3. So yeah, definitely participate in the hackathon. Come to me after if you have any questions. We're running this till Wednesday. So thank you to the sponsors, co-organizers, partners, and hope to see you next time.